Hello my dear friends, welcome to my YouTube channel ANIRUDH'S Chemistry World. This is class 11th Jee, NEET and CBSE class chapter 2nd, that is some basic concepts of chemistry. Okay, this some basic concepts of chemistry chapter is also called as mole concept. Okay, did you understand this? Some people say it's some basic concepts of chemistry and others say as mole concept. Okay, we usually in competitive exams prefer the word mole concept. Okay, basically now I am going to give introduction of this chapter. Okay, I am going to give the introduction of this chapter. See, from the past times, scientists use the scientific methods to discover something, right? And suppose there is one atom. To make calculations and measurements, they use the scientific methods and did lots of calculation and gave some many laws. Okay, and based on them, they calculated the amount of substance, the number of moles, and the terms which are going to be we are using in this chapter. Okay, they use molarity, normality. These words you have been come to if you have already know about this chapter. Okay, scientists previously did research upon these calculations and upon the atom and the molecules. They did calculations in very microscopic level. Okay, they did microscopic level and estimated this. Okay, now we are going in this chapter some basic concepts of chemistry. This comes under, since it is dealing with calculations, always the subject of chemistry which deals with calculations is called as physical chemistry. So this chapter is also coming under the category of physical chemistry. Okay, this is a part of physical chemistry. Okay, now the matter which we are seeing around is mainly classified into two types. That is pure and impure. Okay, the matter which we are seeing around is mainly classified into two types. First one is pure and another is impure. In pure, we have again some classification. This is I am writing about the chemical matter, okay, chemical classification. Based on chemical classification, I will be writing about the physical classification here. But in chemistry, we will focus mainly on the chemical classification itself. So this is chemical classification. Okay, I will be writing here for your better clarity. This is chemical classification. Okay. Chemical classification. Okay, matter is divided into two types: pure and impure. This pure matter is again of two types. First one is elemental, that is element, another is compound. Okay, the pure substances which you are observing is of two types, that is element. You will be seeing the pure form of element, right? Nitrogen, oxygen, some metals if you take iron, aluminium, these all are metals which will come under pure elements. Okay? Now elements are again divided into three types. These elements are divided into three types. Based in the periodic table, you might have been observed if you have ever seen it. Okay, if you don't know about periodic table, we will learn it later. I am going to explain it very clearly. Don't need to worry. These elements are classified into three types. Okay, first one is metals. From your childhood, you have been seeing that metals, non-metals. You might know in your lower classes. You might be studying. Again, I will be telling. These elements are of three types. First one is metals, second one is non-metals, third one is metalloids. Metals, non-metals, metalloids. You might be knowing metals and non-metals, but it might be the first time you are knowing about the metalloids. Okay, let us see. First one is what I call metals. Second one is non-metals. Again, third one is metalloids. Okay, metalloids. Okay, in these metals, I'll be giving the examples. See, aluminum. Okay, iron, sodium, potassium, etc. Calcium. These are all metals. Okay, and in non-metals, see, all these metals are either S block elements or B block elements, and some of the P block elements. Okay, now non-metals are, you might be knowing this: oxygen, nitrogen, chlorine, fluorine, bromine. Right, these are all non-metals. Okay, now metalloids. In metalloids, you'll be having, see, you might heard that about this silicon and germanium semiconductors. These semiconductors are nothing but these semiconductor elements which they use is metalloids. That is metalloids. In these metalloids we have examples: germanium, which is represented by Ge. Okay, G small e, Ge, and silicon Si. These are the metalloids. You mostly use the metalloids. These are important. You need to remember them. Okay. See, for board level it's important. For competitive exams you better see it, because they can pick the question like this, right? Okay. See, in compound, in compounds you will be having covalent compounds. In compounds, and another one is ionic compounds. You might have heard the compounds are of, in your 10th class you might heard that compounds are of two types: covalent and ionic. Okay, in covalent compounds you will be having like AgCl, AgBr. These are covalent compounds. Whereas ionic compounds, in ionic compounds, what is ionic compound? The compound which is formed when the electron is transferred from metal to a non-metal. The electron is transferred from metal to a non-metal, then it is called as ionic compound. You might have heard in your 10th grade. Okay, in ionic compounds you will be having NaCl, KCl, and AgBr also. See, the AgBr. What is AgBr? This AgBr is silver bromide. Silver bromide comes under both covalent and ionic compounds. Okay, but mostly, in most of the cases you will be seeing in covalent. Okay, let it be. You remember one thing, right? No, you just make a note like this. You just see, I'll write this. First I will complete this. Okay, in impure you will be having mixtures. Okay, in these mixtures again two types. In impure, what is impure? Impure is the basicle which is not pure. In mixtures you will be having homogeneous. Okay, nobody is genius. The mixture name is homogeneous. Okay, it's easy to remember. Mixture first name is homogeneous mixture, and second one is heterogeneous mixture. Okay, the two types of mixtures are homogeneous mixture and heterogeneous mixture. Okay, in homogeneous mixture is a mixture which has uniform composition throughout. I will be writing the definition, don't worry. This is the basic classification. In homogeneous mixture you will be having, example is sugar solution. Uniform. See, homo. What is homo? Homo means same. So homogeneous means the solution which has uniform composition. If you see the sugar solution, its uniform composition will be there. You will be nowhere, if you mix, if you stir properly, you will nowhere be seeing the crystals of sugar. It will be mixed well. Okay, it's a uniform composition. It will be having. Okay, And in heterogeneous, hetero means different. Heterogeneous mixture you will be having, example, sand water. Okay, in sand water also you will be seeing the same thing. Where suppose I have sand and water in my hand, okay, like this, and in water, if I pour some sand, it will settle at the bottom and it will not mix at all. If you try to many times also, okay, you just note it down. And in physical classification, the matter is classified into, I'll write about here. The matter is classified into 3 types. What are they? See, the matter which you see around upon physical classification. Okay, is what? Means physically means which you will be able to see. Matter, chemical classification you are unable to see with your eye. Okay, this matter in physical classification is of 3 types. You will be seeing day-to-day life. That is, first one is solids, second one is liquids, then gas. Solid, liquid, gas. That's only solid, liquid, and gas. You just note on this. Yeah, okay. I'll write the examples also. Solid. In solid, you will be having like iron, which is solid. Calcium is solid. Okay, these are solid at room temperature. Liquid. In liquid, you will be having the example of the bromine. Liquid bromine. There is only one non-metal which is liquid. That is bromine Br2. It's very important. You just note down. Bromine. Okay. And water is also liquid. Okay. In gases, you will be having ammonia NH3, gas O2, okay, oxygen which you breathe, and carbon dioxide which we exhale. Okay, oxygen which we inhale and CO2 which we exhale. Okay, you just note it down. One thing you need to pay attention here, that is, see, in some books which I have seen, AgBr, that is silver bromide, is both acting as covalent as well as ionic, but as per the NCERT, I saw different books where the AgBr comes under both covalent and ionic, and in NCERT also it is mentioned both it is covalent and ionic, but in examples they gave only it is as ionic. Okay, we'll go with them. Okay, then in covalent compounds we'll take another example, that is this your organic compound, most wanted the element, that is glucose, that is C6H12. Okay, one thing, did you understand? In covalent compounds you have organic compound, that is glucose C6H12O6, and also you can take other example, sucrose, that is the formula of sucrose is C12H22O11. C12H22O11. Okay, just take this down. We'll go to the next thing, next explanation. It's just a basic idea what is going behind. This is chemical classification, that is physical classification. In pure elements, in chemical classification, pure and impure will be there. In pure, you will be having 2 types, that is element and compound. In element, okay, you will be having 3 types, metals, non-metals, metalloids. In compound, you will be having covalent and ionic. These are just glimpses or summary. In impure, you will be having mixtures. Okay. In mixtures are of 2 types, homogeneous and heterogeneous. I will explain in brief, don't need to worry. Okay, copy it down. or take a screenshot. Yeah. Okay. Done. Next we'll go. See, one thing you need to understand is the whole physical chemistry is based upon your skill, your solving skill. How much you build your solving skills, or how much good you are at mathematics, that much good you will be at physical chemistry. It's not about only calculation, it's all about your logical thinking and applying the formulas, like linking 2-3 formulas and deriving your own formula, like that. In your first chapter you have been seeing, right? You have been seeing, right? E is equals to H nu. Okay, this is one formula I gave you. And C is equals to lambda nu. If you want to express energy and if you want to derive the relationship between energy and wavelength, how will you do? You need to link up these two formulas. It's all about your skill. Okay, in terms of nu, if you it's nu is equals to C by lambda. This is equation 1. This is equation 2. If you say this is equation 3. Okay, we'll go by line. Otherwise, it won't look good. Okay, 1, 2, and 3. Put like this. Means I am just training you how you need to think in the whole chapter. Put put 3 in 1. You get E is equals to HC by lambda. This is one equation you will be getting. Similarly, lambda is equals to H by P is there, and and lambda is equals to H by under root 2m ke. We have already seen that lambda is equals to, that is de Broglie wavelength is equals to H by under root 2m ke. And suppose if you forget this formula, let's say you only know that lambda is equals to H by P, you can derive the momentum P is equals to what? mv. Right? Kinetic energy is what? Half mv square. This is a solving strategy I am telling you. It's a very, 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 very important role it will be playing when you are solving. Kinetic energy is equals to half mv square. Okay? You can write this as half mv into v, right? v into v. This mv you put here. What it will be? Half p into v. If you multiply and divide with m, what happens? This is the magic. M into v is again p. So, into p, okay, mv is nothing but momentum, again by m. Okay, it's p square by 2m. I know, and I already directly know that kinetic energy is equals to p square by 2m. This is the derivation, this is the process you need to apply. Okay, half mv square, you need to get the idea that half mv square can be written as mv into v. In this mv you can substitute p. This is a fast process you need to run in your mind, and it will take time, it will develop very slowly. It's not like if you learn today you will get tomorrow. You need to practice it, right? This is a glimpse, or this is a solving strategy which I am giving from your first chapter. I am just recalling these formulas. You can take like that also. Now, see the element. What is element? In element, what is element? Element is the purest form of matter. The matter which I have seen previously in physical or chemical classification, that is a matter word, keyword we are using here. What is element? Element is the purest form of matter. Okay, element is the purest form of matter. It's a very pure form. Suppose, examples in element. In elements you will be having pure elements. Like if you form, example oxygen, it's a pure oxygen. Suppose let us take simply chlorine, it's also pure. Carbon, it's also pure. Okay, sodium, it is also pure. Like this, the pure elements you will be finding. But in these elements, you will be finding only in the pure form. Means naturally available in the nature. Okay, but this oxygen and chlorine cannot be obtained as nascent oxygen O and normal chlorine Cl. But I am telling you, means element, it is the purest form of matter. Means it is not mixed with any other element. Any other element. Element is the purest form of matter, which is, means in that element you will be having only all the elements, all the atoms of the same element. Suppose this is the element which we suppose this is the beaker. Okay, in this beaker I have let us say, okay, I have not beaker, otherwise it will go to compounds. Okay, you just see this diamond. You know diamond, right? Diamond, it's a three-dimensional figure, but it's not possible to draw the three-dimensional figure. So let us say this is diamond. Okay, don't worry about this diagram. This is a diamond, and this diamond is the purest form of carbon. Okay, diamond is nothing but it will have only all the atoms of the carbon. Suppose this is the diamond, which is the purest form of element. In this diamond, you will be having all the atoms of carbon only. You will not be having any other atom of other element. You will be having only of carbon. Okay, see, this is three-dimensional figure. You also note it down. It will be helpful in your P block elements chapter. Diamond, this is three-dimensional figure. Okay. Now, you did understand about the element. Next, let us go to compound. Let us go to compound. This compound, right? Compound. It is okay. In compounds, you will be having two types. Pure compound, impure compound. In compounds, you will be having two types, that is pure and impure compounds. In the pure compound, you will be having the two or more atoms will be combined, two or more atoms of the same element will be combined. Where impure compounds, where you will be having different atoms of the different elements. Suppose, let us say in pure elements, in pure compounds, you will be having, example, suppose if you take the compound of pure element, that is O2. In oxygen, the bond will be like this, right? The bond between O, that is here only the oxygen atoms only combine in the fixed ratio to form oxygen. No other element is involved. That's the meaning. Okay. O2, N2, Cl2, Br2, and whatever, all the pure elements. And you'll be finding one element rarely. Carbon also, it's not a compound, okay? No, it's an element. S8, you might heard this. S8, sulfur. It's a purest form of compound. And in impure compounds are the compounds which are formed by two or more elements. When two or more atoms of the different elements combine in some ratio, they form impure compounds like CO2, carbon dioxide, NH3, ammonia, H2O, water. This C6H12O6, this is also impure. Because, see, this is because in this, if you see, you will be having three elements. First one is carbon, second one is hydrogen, third one is oxygen. Means it's not a uniform composition of the same element. In this, suppose you have in beaker, you have some C6H12O6. H12O6. In this, you will be having atoms of carbon and atoms of hydrogen and atoms of oxygen also in this ratio. 6:12:6, which is 1:2:1. Okay. You see, if you want to calculate the ratio of the element, suppose in this, if you take C6H12O6, if you want to calculate the ratio of carbon is to hydrogen is to oxygen, what is there? How many times carbon is taken? 6 times. Hydrogen is 12 times. Oxygen is 6 times. C6H12O6. If you cancel with 6 tables, 6 1 are 6, 6 2 are 1, 6 1 are 6. 1 is to 1 is to 1 is the ratio of 6 6 H12 6. Okay. And this is the thing. We just wrote it down. It's a basic information again. No need to worry. We are going step by step. Hopefully I'm explaining better, because these are the things which form the basic concepts of chemistry. The chapter itself is basic concepts of chemistry. You need to learn from the scratch. Okay. You just note it down. Take a screenshot of this. Yeah. Now, you see, I just written just now, because to save your time, if I write and explain, it's going to take more time, and I don't want to waste your time even 1 second. Okay, you just see. Now, we have seen the elements, different elements, and their elements and the compounds and their definitions. Okay, now let us see the symbols, the reason behind the symbols of the elements. Some elements have different symbol, which is completely different from their name. Like if you see sodium, right? Sodium, its spelling is SODIUM. Okay, sodium, but its symbol is Na. See what happens here. Element. Suppose if you take the elements, normal general elements, and their symbols. Okay, elements and symbols. Here in the element, first element we are taking is carbon. Okay, carbon has symbol C. Generally, in the periodic table, the symbols are given such that either the first alphabet is taken from the English name of the element, or the first alphabet is taken from the Latin name. They say first alphabet, but sometimes in Latin name you'll be having different name, right? So, so the symbol is also different. Okay, basically the symbols which are derived from the symbols which are derived for the elements are basically either from Latin word or English word. Okay, so in the element carbon, you'll be having symbol C. Its first element alphabet is C, so it's C. In chlorine, you'll be having first element as C only. Second element is L, since we have chlorine. L is there. Okay. In chlorine, the symbol is Cl. Hydrogen, first element of the periodic table is hydrogen. First alphabet is its symbol. Hydrogen, H. Potassium. Okay, the atomic number of potassium is 19. You might be having known. Okay, you might have known this. And the atomic number of the potassium is 90. And the potassium has the symbol of K. You might ask me, why is this like that? Why it is only K, not P? If you ask like that, see, in potassium, okay, in potassium the symbol is K, because the Latin name of the potassium is kalium. Latin name of the potassium is what? Kalium. In this kalium, the first letter is what? Observe carefully. In kalium, the first letter is K, so symbol is given as K. That's the logic. In sodium, similarly, the symbol is Na, but since the Latin name is natrium, it's taken from this Na. This Na, this Na. Right? See, it's resembling. Okay, this is the logic. Okay, we did not go in depth from where it is derived. I am just telling from where it is derived actually. Now mixtures. Since in the introduction I told you about the mixtures are of two types. In the impure, in matter is divided into impure, and in impure we have mixtures. We have two mixtures: heterogeneous mixture, here is homogeneous mixture. Since similarly, what the same which I have written here is mixtures. This mixture's first mixture is homogeneous mixture. What it is? Homogeneous mixture. What is homogeneous mixture? The mixture which has uniform composition throughout. Okay, if you observe the sugar solution, if you what is sugar solution? Adding sugar to the water and mixing, stirring it well. Okay, where you will never notice even a single crystal of sugar. It will be uniformly spread out. Okay. Now in this homogeneous mixture, the best example is sugar solution. Okay. If you mix the sugar in this water, you'll be seeing very clearly. It will be like water only. You will not able to differentiate between them. Okay. There's no difference. If you even take like this in your hand, it will be having uniform composition. Okay, that's what the meaning is. In anywhere we go in chemistry, one logic is homo. In English or chemistry, whatever is the subject, homo means same. You remember like that. Hetero means different. Just remember like that. Okay. It's a trick, personal trick. It's Anirudh trick. Okay. Nobody gives. It's Anirudh's trick. Okay. Note it down like that. Homo means what? Homo means same. In English, you might heard this homophones. Means right. Homo means the same. Similarly, this homogeneous. Homo means same. Hetero means different. Okay, you note it down this also. Homogeneous mixture. Now you might have understood this. Okay, homogeneous mixture is a mixture which have uniform composition throughout. The mixture has uniform composition throughout the mixture. I told you the example previously. Sugar solution. What is sugar solution? Sugar plus when added to water in sugar solution. Okay. Now heterogeneous mixture. Hetero means different. So different mixture. Heterogeneous mixture is a mixture having non-uniform composition. Is a mixture which have non-uniform composition, or which where the uniform is where the mixture is not uniform. Okay, mixture having non-uniform composition is called as heterogeneous mixture. In the example, best example is sand plus water. That is sand water. If you add sand to the water, what happens? All the sand particles will be settling down, and if you even stir, and it will come up for some time, and again it will go down and settle at the bottom of the vessel. Okay, so the example of heterogeneous mixture is sand plus water. This is the best example. Okay, if we leave the chemistry for this time, I am telling you, actually if I tell this as per chemistry, it's wrong, but for your understanding I am saying. Did you ever see the precipitate? Yeah, you might have seen this precipitate, that is AgBr or AgCl. You might have observed this. You see this AgCl and AgBr. In your 10th grade, in the 10th grade, the chemical first chapter, chemical reactions, you might be learned this. Precipitates, about precipitates. In double decomposition reactions, you will be seeing the formation of a precipitate which will be settling at the down, right? That is, this is precipitate is symbolized with like this down arrow mark. Okay, like this. Okay, this big representation I gave for your understanding. Now AgCl and AgBr, that is silver chloride and silver bromide, are precipitates. Okay, these two precipitates, what happens is, when you add silver to chlorine or silver to bromine, what happens is, it will, you will be, directly you cannot obtain this. In the double decomposition reaction you will be seeing. Okay, if you want the correct reaction also I will give. See, ACl plus AgNO3 gives AgCl plus KNO3. Okay, this is the reaction which you have seen previously. Other reactions you will be seeing. There were n number of reactions. Let us say KCl plus AgNO3. Okay, KCl plus AgNO3 gives AgCl, double decomposition. This will decompose this will take this, and this will take this. AgCl plus KNO3. Where AgCl is a white precipitate, you might have learned this. AGCL. You might have known this, okay? AGCL. This AGCL, what happens is, it will settle at the bottom of the solution. If you mix a KCl and AgNO3 in the beaker, this AGCl will be settling at the bottom. Even if you still, it will not mix. This is the thing similar to this of heterogeneous mixture. This is a very best example. As per chemistry, I cannot say precipitate is heterogeneous mixture. No, it's not at all valid. But for your understanding, to imagine the precipitate, if you understand, you will be understanding about heterogeneous mixture. Similar, this sand water also is a similar example. It's a best example. It's not an example. It's your understanding. For your understanding. Okay. This AGCl will be settling at the bottom when you do this reaction. Okay, this is the type of heterogeneous mixture which I have observed when I have studied and took this example. Okay. Okay. Now, this is very important. Very important. Where you will be having more number of JEE, NEET and NCERT questions. See, mostly in competitive exams you won't be, without this there is no calculation at all. Somewhere or other question you will be seeing, at least if you solve some 5 questions, some 3 questions it will be involved with this. Especially in physics you will be seeing more, and chemistry also not less, you will be seeing more. Okay, you just see this, mostly used prefixes in chemistry, okay, or in physics also, mostly used prefixes. These prefixes are nothing but 10 to the power of something, 10 to the power of some number, they will be having some names, specific names. So mostly used prefixes are these. Now, very important, because in question, in anywhere you will not be seeing this. In question, you will not be given this. You will not be given this, and you will stuck up there. And so I saw most of my friends who did this mistake. They didn't know this prefixes and face the problem. Even though they know the calculation, they confused between pico, what is pico, and nano. They confused. Question went wrong. Instead of +4, you will be getting -1. Okay, it's very big mistake people do. Okay, you just learn this. You need to revise and write on your in front of your table and revise them daily. You will be getting in 2-3 days. That's it. See, 10 to the power of -15. 10 to the power of -15 is femto. 10 to the power of -12. Okay, is pico. This is very important. See, personally, I too got the question in this JEE mains and my state board exam, state level competitive exams, which is EMCET. This 10 to the power of -12 is very important value. 10 to the power of -12, very important value, because people won't remember this. Generally we will know the micro, nano we will be using regularly. We won't use this regularly. Suddenly you will be given the question that 1 picometer. What you will do? You need to understand. You need to study. Okay. 10 to the power of -15 is femto. 10 to the power of -12 is pico. It's represented by pi. Okay. 10 to the power of -12 is pico, represented by pi. Very important. 10 to the power of -9 is nano. Right? You might be seeing this wavelength given in nanometer. 10 to the power of -9 nano. 10 to the power of -6 micro, represented by mu. 10 to the power of -3 is milli. 10 to the power of -2 is centi. You might be knowing this already. 10 to the power of 3 is kilo. 10 to the power of 6 is mega. These are also very important. Similar to that of pico. More than pico, I can say giga is very important. Gigabyte. You will say, you will calculate the MB. You will calculate the data in 1 gigabyte. What is 1 gigabyte? It's 10 to the power of 9 byte. Okay. 1 gigabyte is 10 to the power of 9 byte. So 10 to the power of 9 means giga. 10 to the power of 6 is mega. 10 to the power of 9 is giga. 10 to the power of 6 is mega. 10 to the power of 9 is giga. Very important. Note this. You just note down this. I'll give you 10 seconds. You just take a screenshot, please. And don't forget to subscribe my channel. this is an encouragement for me, and also I'll be making more videos and tricks for you. So kindly subscribe my channel. I so that it will be very helpful to the students like you. Okay, and also you will be benefited because I personally have some tricks. I'll where no teacher will give, so because they don't have time, but as I have time, I'll be sharing with you and make time. I'll create time for you and do it. Okay, take a screenshot. You just see this now. See, we just entered into the real concept. From here, you need to focus more. Till now, we just see the things which we need to understand, the keywords to be understood for doing questions. Okay. Now, you will be seeing this important things. Okay. Let us start. International system of units. What does this international system of units mean? Okay, this international system of units means SI unit. This SI units full form is international system of units. Okay, in this you will be having 7 fundamental physical quantities or 7 base quantities. Okay, in SI units, to express SI units, you will be having some physical quantity, right? For suppose meter is there. For meter, what is the physical quantity? Physical unit is this meter. For that, what is the physical quantity? The physical quantity for meter is length. Similarly, for this SI units, you will be having some physical quantities. Okay, there are 7 base units. Okay, if there are 7 base units, there are 7 fundamental physical quantities. They are physical quantities length, which is in physics you might be having this length, mass and time dimensions. That is, length dimension is L, mass dimension is capital M, and time dimension also time capital T. Length is also capital L. Okay. In this physical quantity, you have 7 physical quantities, fundamental physical quantities. For these 7 fundamental or base physical quantities, you will be having 7 units, SI units. Okay. For the first physical quantity is length. For length, you will be having unit as meter. See, its representation is M. Mass, its unit is what? Kilogram, represented by kg. Time, its SI unit is seconds. That is represented by S. And temperature, okay, temperature, you will be having SI unit as Kelvin. Always you will be seeing in thermometer also, not this thermometer, in chemical labs. Okay, in chemical labs you will be having thermometers. There, you will not be seeing in Fahrenheit or Celsius. You will be seeing in Kelvin only. So, the temperature is always expressed in unit of Kelvin, and this Kelvin is symbolized as K. Now, 5th physical quantity, which you will be studying in current electricity. You will be dealing with that circuits and all. That is current electricity chapter in your 12th grade. So for this, at this stage, understand it. Electric current. Oh yeah, I remembered one thing. In your 10th grade, you might be having this electricity chapter. Okay, there you have learned this electric current. The electric current represented by I has SI unit ampere. Ampere or ampere. Okay, unit is A. And the amount of substance. This is a new thing. In the first chapter also, I used the term mole. Here's that is. Okay. 6th, physical quantity. This is not correct. You can write in any order. I am writing like this. Okay. As per the book. 6th one is amount of substance. Okay. In this amount of substance is a physical quantity where you will be having the unit moles. The moles are symbolized with a letter small n. The moles are represented by letter small n. You just remember this. I highlight it. Okay. The moles unit is symbolized by n. Amount of substance is nothing but moles. You suppose I have one glass of water. How much you will be measuring? It's a very macroscopic level, microscopic level also. So if you have some Okay, in class for chemistry, in okay, in test tube, suppose you have like this. In this you have some chemical. Okay, you will be measuring in terms of moles. Means amount of substance. How much amount is there? You will be measuring in terms of moles. Represented by n. And this we won't use. It's not important. Not much also. It's not important at all. Okay, it's not important. You will be having nowhere questions. But you need to understand this. If you in board exam, if you ask to write all 7 base units or fundamental units, you should be able to write. So that's why I'm telling. 7th physical quantity is luminous intensity. What it is? Luminous. You might have observed this tube light. Okay, other stabilizers. Luminous company, right? Luminous. Okay. Similarly, luminous intensity. What it is? Luminous intensity. This luminous intensity represented by IV. What it is? I. Okay, I is there, right? I to the subscript V. This luminous intensity is represented by IV. The unit of luminous intensity is candela, represented by CD. Okay, please note it down. Take a screenshot. I'll give you 5 seconds. Okay, now let us go to scientific notation. Everywhere, if you go in any question or in board exams, he will ask always to express in scientific notation. If we don't ask to write in scientific notation also, you need to express. Sometimes what happens is, if you get a question of 4 marks, and if you write even though answer is correct, you will get only 3 or 3.5 for max. 3 or let us say 3. You will be losing 1 mark because you didn't express that quantity in this scientific notation. This scientific notation plays a key role till your completion of your 12th. Okay, what is this? Scientific notation. Okay, scientific notation is represented is what? A into 10 to the power of b. The scientific notation is represented as it expressed as A into 10 to the power of b. This A into 10 to the power of b is called as scientific notation. Okay, A into 10 to the power of b is called scientific notation, where this A is called as base. Where A is called as what? Base, and B is called as, okay, in general you can say B is power or degree. B is power or degree, but in terms of scientific notation, if you say, you need to call it as order of magnitude. Okay, in scientific notation, what is A into 10 to the power of B? It's a scientific notation form. Okay, and where A is the base, B is the order of magnitude. What it is? Order of magnitude. Okay, order of magnitude. B is called as order of magnitude. In this order of magnitude, you need to understand this one catch. In this order of magnitude, that is B, you will be having some questions where he will not mention as 10 to the power. If you have, suppose for example, say let us say 10 to the power of 5. Suppose in question he want to express you, he want to tell you that in question it is 10 to the power of 5, but he will not directly give. Sometimes if we want to make it complex question, he won't give as 10 to the power of 5. Instead he will tell the order of magnitude is 5 or magnitude is 5. You need to understand. There is no way. So if order of magnitude is given or magnitude is given, you need to express like this. If you have 10 to the power of 5, okay, some quantity is say 3 into 10 to the power of 5. And mostly he will not ask like this much complex. So this is enough. If you have 10 to the power of 5, he might say the order of magnitude is 5 for this quantity. If the order of magnitude is 5 for this quantity, means the quantity is 10 to the power of 5 directly. You should understand. That's the thing. Okay, let us do this example for your understanding. Example: express 391.5 meter into scientific notation. Okay, express this quantity into scientific notation. What is the scientific notation? A into 10 to the power of b. One thing. We missed one point. Here A, this base, right? Here A value should always lie between 0 to 9, 9.99. Means the A value, I'll write here, okay, let us write here, the A value must lie between 0 to 2. In mathematics, in sets, you might have been learning, you might have learned this less than, strictly less than. What does this mean? A strictly less than 10. Okay, A strictly less than 10 means A must be less than 10. It should not be equal. Means A shouldn't be equal to 10. If it is equal, then what's the use? You can directly write 10 to the power of something, right? So A should be strictly less than 10. That is the rule of the scientific notation. Scientific notation, A should be lying between 0 to 10. Okay, express this into scientific notation means in 391.5 you need to express as 3.915. Okay, 1 in 391.5. 3.915 you need to write like this. How many places it went left side? 1, 2. Right? 1, 2. So you need to express as 10 to the power of 2. You can write like this. Okay. So this is 3.915 into 10 to the power of 2. Where base is, that is A, is equals to here. If you compare with this with A into 10 to the power of 3, A is 3.915. B is 2. Okay. B is 2. You need to understand this. Okay. Take a screenshot. Okay, we completed this first part of the video. The next part of the video we'll resume. Okay, we'll see. Just revise the notes till now. What I gave, and also the examples, tricks, whatever I gave. You just revise it. Go through the notes. Okay, and then start from here. Okay. Hello friends, now this is the second part of the video. First part I have already completed. You just check it and rewind this. Okay. Now, previously we have studied about the scientific notation, right? A into 10 to the power of B. Now this is a continuation of it. Addition and subtraction in scientific notation. Okay. We need to add and subtract the numbers in scientific notation. Okay, what is scientific notation? Let us just focus at this point. Scientific notation is nothing but A into 10 to the power of B. Okay, scientific notation is A into 10 to the power of B, where A is the base and B is the order of magnitude. I previously told this. If you have any doubt, you just rewind the video. B is the order of magnitude, A is the base. Okay. Now, the A value should always be expressed between the values of 0 to 10. Okay, means 0 and 10 are not included. Okay, here is equals to is not there, it's just a inequality. Okay, A will always lie between 0 to 10, means the values will be from 0.111 something to 9.999, means it takes these many values. Okay, right, you need to not 0 also, not 0.1. So from 1 you can say, you can take it, means from 1.00001 you need to take till 9.9999. Okay, means you did not remember like this. Always the A should lie between 0 to 10. That's it. Okay, and the main rule behind addition and subtraction in scientific notation is that the power of the 10 must be same for the two numbers which you are adding. I'll give the example, but you need to remember this rule. And if they ask in the board exam, you need to write this point clearly by giving the proper example. Okay, to add or subtract numbers in scientific notation, okay, the power of 10 must be same. I'll show you. To add or subtract numbers in scientific notation, the power of 10 must be same. Okay. Suppose I'll give you one question. Say two numbers. We need to add in scientific notation only. So suppose 39.5. Okay. Plus. Okay. This is simple question. I'll give you 3.95. Okay. We need to add these two values. Okay. In scientific notation, if you want to express, the powers of 10 must be same. Okay. Say here I'll write 3.95 into 10 to the power of 3. Okay, 10 to the power of 3. And here it is. You should express this. 39.5 can be written as 3.95 into 10, right? Isn't it or not? 3.95 into 10 is 39.5 plus 3.95 into 10 to the power of 3. According to the rule, we need to add or subtract the numbers if and only if scientific notation, if the power of 10 is same, okay? But the power of 10 is different. Here it is 1, here it is 3. Either you need to convert this 10 power 1 into 10 power 3 or into this 10 power 3 into 10 power 1. But according to the rules of scientific notation, better we'll do one thing. We'll express this into 10 to the power of we'll express this into 10 to the power of 1 format. Okay, 3.95 into 10 plus 395 by 100 into 1000. 10 power 3 is nothing but 1000. 2 cancel, right? 3.95 into 10, right? Into 10 plus 395 into 10. Here this basis, here the power of 10 is same, that is 1. Then we can directly add them. Okay. What's the value? 395 plus 3 is what? 395 plus 3 is 398. Okay, plus 0.95 is there here. Here since point is not there, you need to take as 395.00 plus 3.95. For your better understanding, I am writing clearly. 5 plus 3, 8 and 398.95. Okay. Here, another method. This is the first method, and second method. This one also you can do. That is 3.95 into 10 to the power of 1 plus 3.95 into 10 to the power of 3. This is there, right? You can express this into 10 to the power of 3 format. Here we expressed into 10 to the power of 1, say as a same power of 10. Here we are expressing into 10 to the power of 3. How we can do this operation? You just understand. We need to just, the simple task is, okay, I will leave the space here. This 3.95 into 10 to the into 10 it is there. Now to get 10 power 3, how much we need to multiply? We need to multiply with 100. By multiply and divide with 100. Okay. This kind of tricks you need to apply when solving the previous year questions. Sometimes you will be confusing where the decimal places goes towards left or right. Better you multiply and divide if you get any doubt. 1, 2, 3. Here we get 10 to the power of 3. That is 3.95 into 10 to the power of 3 by 100 plus this value. Okay. Now the decimal moves left side when it is divided, right? So 0.395. It becomes like this. Okay. 3.95 by 100. The decimal moves left side towards 2 places. So 1, 2. This is the value. Okay. Into 10 to the plus 3.95. We can take this common 10 power 3. This is into 10 power 3. The value will be same again. There is no change. Okay. Here you will get what? Okay, I'll write like this. 0.0395 plus 3.95. Okay, if you add 5, 9, 3 plus 5, 8, 9, 3 point, what we get? 3.9895 into 1000. It again becomes the same. Okay, sorry. 1 minute. 1, 2, okay. 0. Okay, 1 minute. here we need to check it once. Yeah, 10 power here into 10 we did not do, so that is 3989.5. This is the result. The same we are getting, right? Into 10 to the power of 3 is nothing but 1000. So 3.30. This moves 3 places right side. 1, 2, 3. So 0.5. Okay. 3989.5. In the two cases we are getting the same answer. Okay. But I prefer this method because if the zero will come before the decimal point, it's difficult to calculate in your mind. Okay. Now just note this down. These are the rules which are also useful in your MCQs type models and also board level questions. Okay. Sometimes they will ask the example along with the rules. If they won't ask, suppose if they ask for 4 marks, write down the rule of addition and subtraction in scientific notation. If they ask for 4 marks, if you write only the definition, he may only give 1 or 1.5 mark. But if you explain with the example, you will be getting the full marks. Okay. According to your wish, you can prefer any of the two methods. Okay. Now let us see this. After significant figures, we will come to this. It's not that important. You generally know previously how to round off. But see this rules of significant figures. Okay. Basically, see, you don't need to understand the definition of significant figures. We need to only understand the rules of significant figures. These are all non-zero digits are significant. What does it mean? All non-zero digits are significant means except the number 0, from 1, 2, 3, 4, 5, 6, 7, 8 and 9, all the numbers are significant. All the non-zero digits are significant. Means except 0, all are significant. Okay. And in that also we have some exceptions. Now we cannot say by seeing the question every 0 is insignificant. No, not like that. But we have some exceptions. Okay. The zeros between two non-zero digits are significant. Study second. The zeros between two non-zero digits are significant. Suppose I will give you an example. Okay, I am arranging this. I will write big examples. Okay. Take a screenshot if you don't. If you are not taken till now. Now I will give you an example, proper example for you. We are here, right? The zeros between the two non-zero digits are significant. Yeah. Let us take an example. 3.90056. This is just an example, just see it. According to this, the zeros between two non-zero digits are significant. You may tell me, you may tell that all non-zero digits are significant. Why here zeros will be significant? Because according to the rule, the zeros which are present between the two non-zero digits, 9 and 5 are two non-zero digits, right? So these zeros between the two non-zero digits are significant. So count how many significant figures are there. Count the number of significant figures. Significant figures, or you can also say significant digits. Okay, significant digits. Okay, count the number of significant figures in this. All non-zero digits are significant. First you count that. How many are the non-zero digits? 1, 2, 3, 4. 4 plus the zeros which are lying between these two non-zero digits are significant according to the two. So 1, 2. So 4 plus 2, 6 significant figures are there in this number. Okay. And again, I'll also tell you this. See, this is first example in this, and this is the second one. 6 significant figures. SF we can write as shortcut. So if I give this example, 0.05690105. Okay. Let us say in this first of all, if any number is given, you count total number of non-zero digits first. So if it is an MCQ, you can directly eliminate one option. Okay, if you have this non-zero digits more than the significant figures in the question in the MCQ value, you can eliminate that. I'll also tell you that. Don't worry. See, there's no rule that if you get 0 before the decimal point is significant. So the 0 before the decimal point is insignificant, means not significant, and this 0 is also not significant. If you see, the first significant figure in this is 5. We have the zeros will be significant if and only if the two two non-zero digits are there. Means two zeros when present between two non-zero digits other than 0, then they are significant. Unless they are not insignificant only. Okay. Here the zeros are there before the first significant digit. Okay. Here these two zeros are not significant because there's no number before this. Okay. So these are not significant. Here 1, 2, 3, and zeros between two significant two non-zero digits are significant. So 3, 4, 5. 1, 2, 3, 4, 5. So 5 significant figures in this example. Okay. Now let us completely read this and we will do another question. They are simple questions. They may be asked in your board exams, not competitive exams. Okay. The trailing zeros after decimal point are significant. Okay, the trailing zeros after decimal point are significant. Means, what are trailing zeros? I will show you. Trailing zeros. Okay. If you have a number like 3.9500. Okay, if you have a number like this, then if I ask how many number of significant figures are there, first count non-zero digits. How many are there? 1, 2, 3. 3 non-zero digits are there. And according to this rule, the trailing zeros after decimal point are significant. Means trailing zeros are nothing but the zeros which are present at the last. Means last doesn't mean that if I write 9000, these are not trailing zeros. The zeros which are present after the decimal point and after one non-zero digit are trailing zeros. Okay, I hope you understood this. The zeros which are present after the decimal point and if there is a non-zero digit before it, they are trailing zeros. Okay, you simply remember as the zeros after the decimal point are trailing zeros. In this, 3 non-zero digits are there, plus since these are trailing zeros are significant. So 1, 2, 3 plus 2, 5. Sorry, 3 plus 2, 5 significant figures in this. Okay, similarly I will give you one question. 395.756000000. Okay. Okay, tell me how many. Okay, I will make this complex somewhat, so you will be able to understand easily. Let us say this. Okay. Tell me how many number of significant figures in this question. 0. I will read it out if it is not clear. 03950.56000000. In 6 zeros, 1, 2, 3, 4, 5, 6 here. Okay. See here this 0, since it is there's no non-zero digit before it, it's not significant. So insignificant. Let us not count this. So first of all, count all the non-zero digits. 1, 2, 3, 4, 5. Okay, 5 plus. It will be an easy thing. You need to make a habit like this. Okay, 1, 2, 3, 4, 5 plus. The zeros between the two non-zero digits are significant. So 1, 2, 3, 4, 5, 6, 7. So how many zeros are significant here? This is zero between the non-zero digits. These are trailing zeros. How many trailing zeros? 1, 2, 3, 4, 5, 6. 6 plus 1, 7. So 5 plus 7 is 12 significant figures in this number. Okay. This is a high level question. You may get these type of questions in competitive exam, and he may also twist like 12 significant figures, round off to two significant figures if he asks. No, he may tell you like this. Okay, the answer is some x, and x is equals to yeah, and answer is like you need to express as x into 10 to the power of 3 plus 5. You may ask question like this, and x is nothing but number of significant figures. Okay, okay, right. 12 into 10 to the power of 3 is 1000, that is 12,000 plus 5, that is 12,005. And again he may twist like this 12,005, round off this to two significant figures. You may ask, two significant figures, make this number such that there are only two significant figures. This is a JEE mains level and a NEET level question. Two significant figures means how many are there here? 1, 2, 3, 4, 5. Trailing zero, the zeros between two non-zero digits are significant. So 1, 2, 3, 4, 5. 5 significant figures. You need to convert this to two significant figures. How is it possible? Once think. Okay, two significant figures means if you remove this 5, what happens? These are not significant. Then it becomes two significant figures. But you need not change. You shouldn't change the units. You shouldn't change the place of the number. Means this is in 12,000s. Means in 10,000s place. You are getting my point. You shouldn't change from 10,000s to thousands or thousands to hundreds. Instead, you need to convert like 12,000. You should round off this to two significant figures as 12,000, not 1,200. Because from 10,000 digit place, you shouldn't change to thousands place. You should see such that the place of the number won't change. Okay. This is a very high level question. If you don't understand, let us leave this for this stage. If you understand, well and good. If you don't understand, I'll however make another video based on solving. Okay, this very high level question. If you get solving this question, you will be easily doing units and dimensions chapter also, which is there in physics, and also this chemistry chapter, some basic concepts of chemistry. Okay, now this is the important thing. I already told that zeros before the decimal point are insignificant. Okay, this zeros before the decimal point are insignificant, not significant. The exact numbers have infinitely many significant figures. What does exact numbers mean? Exact numbers like integers 2, 3, 5, 100. These are exact numbers. Means according to the situation you can write the points. For 100, how many after zero point? How many zeros you can write? You can write any number of. If I fill this board also, I have from here to here, the zeros, it will not be completed. You can write any number of zeros according to situation. So that's why the exact numbers have infinitely many significant figures. Okay. And like here pi, it's a constant value. What's the value of pi? Pi is 3.14. Okay, or 22/7. Okay, this 3.14 is an exact value. After 14 you can keep any number of zeros. In Boltzmann constant you will be having in this modern physics, and Planck's constant, R is the universal gas constant. These are constants, all constants. You can write exact numbers along with all constants. All constants and exact numbers have infinitely many significant figures. Okay, just copy this down. Now rounding off, it's a very simple concept. See, suppose I have number like 5.96, you need to round off to two significant figures, two significant digits. What you will do? 2 means 5.96, you need to round off to two significant figures. Means you need to, this 6, which is greater than 5, right? 6 is greater than 5. So you need to add 1 to the preceding digit. So 5.9, 9 plus 1 is what? 10. So you need to write 6.0 is the correct answer for this. Okay. Similarly, 5.74. 5.74, you need to round off to 2 significant digits. Here again there are 1, 2, 3, 3 significant digits. You need to round off to 2 significant digits. This 4 means there are 3 significant digits. See, 3 significant figures. This you need to convert to 2 significant figures. How is it possible? By rounding off this, right? Rounding off means you need to round off. We will suppose you got some 89 marks out of 100. You will tell somebody that you got 90 marks instead of 89. It's a simple word. You are rounding off 89 to 90 marks. Okay, this is a simple thing. If you want to understand, you comment me down. I'll make a separate short or some 5-10 minutes video based on rounding off more rules. But it's not much important. The significant figures are much important. So let us see this for at this stage. Rules. If you want rules, you should better study from NCERT. You will be easily understanding. Then listen to this first and then study there. Okay. This 5.74. This 4 is less than 5. I'll write the rule. 2 important rules in rounding off. You just write down. I'll write the rule. 2 or 3 rules. I'll write which are there in NCERT. Again, it will be trouble for you. I want you guys to just relax and study. I don't want to study this book, that book, that book. No, that won't work. Okay, studying only following only one lecture and one proper notes is enough. No need to go to NCERT also. If you go to that inorganic chemistry, there you need to go through NCERT. But studying line by line won't work for competitive exams. Okay, and see for NCERT also, for CBSE exams, the short notes is very easy to understand. If you ask even for 5-6 marks, you can easily elaborate. If you understand the concept, you can elaborate by giving the exams. No need to worry. Except in that inorganic chemistry, you need to remember some parts. There you need to see, just to skim that too. In physical and organic, no need to touch NCERT. That's it. Physical first, organic leave it. Physical part, you no need to touch textbook, no need. Just go understand formula, concept, leave it. That's it. First, just directly jump into the problem solving. Okay. Problems. What's the rule here is, there are 2 rules. So okay, I'll write the rules, all the rules, no need to go to NCERT again. Okay. If the rounding off okay, if the rounding off number, okay, just write this examples once. The concept is rounding off, it's very easy, you just see. Instead of this, I'll write the proper word. If the number to be dropped, is greater than 5, greater. Okay, I'll write in words again. Some people won't understand the greater than and less than. Even many of my friends also face difficulty. Even I till 9th class I didn't understand the greater than and less than. I used to solve easily all the problems, but this greater than and less than I used to confuse. Okay, it's a natural thing. If you see 9, 5, greater symbol is this. Okay, greater side. Where you have this opening curve, that is greater, and where you have this emerging intersecting part, it is less than. Okay, 9 greater than 5, 5 less than 7. Okay, this is, if you want to express the number greater than as, then you need to express like this. If you want to tell some number less, you need to write like this. Okay, if I tell A is equals to 1, B is equals to 2, C is equals to 3, you need to write as C greater than B, 3 greater than 2 greater than 1. Okay, C greater than B greater than A, or A is less than B is less than C. If you want to express as greater symbol, means this is the descending order, this is the ascending order. See, this is just a small thing. This basic thing I want to explain. I want to explain from scratch. Okay. If the number to be dropped is greater than 5, okay, if the number to be dropped is greater than 5, if the number to be dropped is greater than 5, then add the preceding digit, in the book it is given as raised, and instead of raised, then add the preceding digit by 1. It's a very, you need to understand a simple language. In the book it is given that if the number to be dropped is greater than 5, you need to raise the preceding digit by 1. Instead of raised, we can use the word add. You can then add the preceding digit by 1. Okay. Suppose, example, you have the number, if the number to be dropped is greater than 5, greater than 5 case, so, okay, 8.97, and you need to round off to there are 3 significant digits, right? You need to round off to 2 significant figures. What you will do is the number to be dropped, the dropped means you are focusing that value by manipulating that value, you need to convert it. Okay, dropped means we are focusing on that value only, whether it is greater than 5, less than 5, or other thing. Okay, you need to this number is to be dropped is greater than 5. The number to be dropped is greater than 5. Since 7 is greater than 5, so then add the preceding digit by 1. So 5 is greater than 7 is greater than 5. So add the preceding digit by 1. What happens? 9 plus 1, 10. So 1 carry, again it will be 9.0. Some people what they do is, see, 8.97, is that right? They follow the rule perfectly. 7 means greater than 5, okay? They will add 1. 9 plus 1 is 10. Okay, they'll write 8.0. Just think, from 8.97, how it goes to 8? No, it's not the logic. It goes to 9.0. That's small things. You will be understanding. I know you will be understanding the things which I tell you. Okay, now if the number to be dropped is less than 5, it is less than, okay, if the number to be dropped is less than 5, okay, then the preceding digit, then the preceding means what? Previous digit. Then the preceding, that is previous digit, preceding digit is retained as such. Retained means remained as such. Means if the number to be dropped is less than 5, then the preceding digit is retained as such. Means example, you will understand these all things by seeing examples only. Suppose 8.94. Okay, this 4 is less than 5, right? So according to the rule, then if the number to be dropped is less than 5, then the preceding digit is retained as such. Means its preceding digit won't change. By means you may think you will write as it is 8.94. No. It remained as such means you should drop this. Means you need to write 8.90. Okay, I'll give another example. 97. Okay, 94.85. 854. Okay, if you want to round up this, we will remove the point, you will confuse. 956. Okay, I'll write 9564. 9562 I'll write 9562. Okay, this is less than 5, so its previous digit is remained as such. So 9560. This is in this way you need to round off. Okay, right? After this, so see this. I am giving this you as a homework. You comment me down the answer. Okay. RO means round off. Okay. RO means round off. Okay. Round off to. Okay. I didn't write this right. Round off to two significant figures. Two significant figures. SF means significant figures, RO means round off. These are very basic rules. Okay, you may think I'm taking more time on this, but investing time in this is very important. Okay, I'll tell you two rules. These are also important. Take a screenshot of this, right? Take a screenshot of this. Yeah. I'm rubbing this, okay, right? Okay. Now, the third rule, which we are going to see is, if the number to be dropped is equal to 5. Here the real rounding off starts. Okay. If the number to be dropped is equals to 5, means we are rounding off the number we are rounding off means we are truncating dropping the value of 5, and its preceding digit is odd. Okay, is odd. First case, second case we will see. If this is odd and second case is even. If this is odd, then its preceding digit, okay, I read this right, and its preceding digit is added or raised by 1. Means if the number to be dropped is equals to 5, then the preceding digit and this preceding digit is odd. Or suppose if you have a number like 5.9 935, okay, if you want to drop the number 5, if the number to be dropped is 5, then its preceding digit, if it is odd, okay, then you need to raise this, add this by 1, you need to remove this 5. Okay, first of all, make the number which is there as 0. Remember that blindly. 5.9, 3 plus 1 is 4. This is the rounding off way. And if the number to be dropped is equals to 5 and its preceding digit is even, then it is remained as such. Remained as such. Remained as such means, see, if the number to be dropped is equals to 5, then the preceding digit is even, then the preceding digit is remained as such. It means here preceding digit. Preceding digit. Similarly here also, it means preceding digit. I write here. Okay. Yeah, even. If it is even, like 5 point, we'll just change the number, 5.925. Okay, if the preceding digit, if the number of to be dropped is 5 and its preceding digit is even, then the number is retained as such. Means we need to make this as 0. If we are dropping any value, we need to make that as 0. Remember that. 5.90, so 5.92. That's it. Okay. This is the case. Okay. So, sorry, don't write 0. 5.92, it's enough. You need not, sorry, if the number to be dropped, the dropped number disappears. It will not become 0, it disappears. That is, you don't need to write. That's the rule. Again, in this you have some special case. That is, if the number is like 3.9596, yeah, and if you want here in these cases, the rounding of digit, ending digit is also 5. But if you want to round off here 1, 2, okay, we don't need to take point. 3954. Okay, if they are 3954, 3954. If you have this value, if you want to round off till, if you have 4 significant digits, right? From 4 to 4 significant figures, you need to convert to 2 significant figures. Then you need to round off 5 here. 5 only you need to round off. Here, since the preceding digit is odd. Okay, here you need not see odd. See, if the preceding digit in this case, see, remember, just see this. We are converting 4 significant figures into 2 significant figures. Okay, if you are rounding off, you need to raise it by 1. It becomes 4,000. No, not 4,000. Wait. Yeah, you need to. Yeah, it's not possible to 2 significant. It's 3 significant figures you need to round off. You need to round off. See, 3954. If you want to round off to 2 significant figures, it's only possible when you make that 3, not 3. Wait. Here's one catch. You can only make 1 significant figure in this case. That is 4,000. You will be only having 1 significant figure here. Okay. This one. Because see, 3954. Here, if you want, just think. Don't go to in depth. Just understand basically. Just skim this. 3954. This is 5. If you round off, you need to round off to 1 significant figure. There are 4 significant figures. What you will do only possible is, see, 3954 between 3000 and 4000. So 3900 and 4000, which is close. It is close to this. So you need to. It is 4000, not 3900. You will again have 2 significant figures. This is the understanding. This is very high level. This is optional, I can say, because I didn't see any more number of questions on this. If in JEE mains, if you have some 100 questions, if you have 1000 questions, I saw some 2 to 5 questions, 3 to 5 questions. That's it. Based on this, that is also not possible. Okay, just better you note down till this. Otherwise, you will confuse. It is mentioned in NCERT also, but it's very high level to understand. Okay, now let us see the average atomic mass. What is this concept? Average atomic mass right? I call this average atomic mass as it's a shortcut, right? AAM. It's a very short, easy shortcut. Average atomic mass is equals to, the average atomic mass is equals to sigma, means summation of percentage abundance into atomic mass per 100. It's a very important formula. Very important formula. Okay, I'll give star mark also. Average atomic mass is equals to sigma summation of percentage abundance into atomic mass by 100. You need to remember this, however, it's important. Average atomic mass is equals to percentage abundance into atomic mass by 100. Is equals to, let us repeat 3 times. Average atomic mass is equals to sigma percentage abundance into atomic mass by 100. Average atomic mass is equals to sigma summation of percentage abundance into atomic mass by 100. Average atomic mass is equals to percent sigma summation of percentage abundance into atomic mass by 100. Okay. Similarly, it's average atomic mass. Here, average molecular mass also there. Okay. It's similar formula. If you get one thing, you get another thing. Average molecular mass is equals to summation of sigma percentage abundance into molecular weight by 100. This is another formula. This is a very important formula. See this question. See, and you do understand this average atomic mass is equals to summation of this sigma. Sigma means adding all. Okay. Sigma percentage abundance into atomic mass per 100. Okay. This example, this question, which came in JEE mains. Okay, it came in JEE mains, CBSE. Okay, means board exam, and also this is the. I think it came or not, but okay. It's a very high level. It's easy. You can also take it for CBSE, but it's a PYQ for. It's a PYQ of JEE mains, a PYQ of JEE advanced. You believe it or not? It's a JEE advanced PYQ. Or this easy question, formula based question directly came in advanced. See, PYQ of JEE mains, PYQ of JEE advanced. That is IIT exam. Okay. The students who are preparing for NEET, it is also very useful for them. They will also get some formula based questions. Okay, example. Calculate the average atomic weight, that is average atomic mass of iron, if the abundance of isotopes of iron are 5%, 90% and 5% respectively. Study this again. Calculate the average atomic mass or average atomic weight of iron if the percentage abundance of isotopes is 1, 2, 3 isotopes is this much. Means first one thing is the strategy of solving this is, see, summation means or sum. Summation means sum, means adding all of them. Here what is this formula? Average atomic mass. Calculate the average atomic mass of iron. So average atomic mass of iron. Fe. Fe means iron. Okay. Ferrum. Average atomic mass of iron. Average atomic mass of iron is equals to sigma. Means summation. You need to add. You need not write summation. Average atomic mass of iron is equals to percentage abundance. You need to correspondingly take this. This for this means average atomic percentage abundance into atomic mass is how much? It is mentioned in 54. Atomic mass by 100. Okay. Plus. Okay. Plus. Again, percentage abundance of this one 56. Iron 56. Average atomic mass of iron. Percentage abundance is percentage abundance into atomic mass by. Sorry, 56 is this is 56 take. 56 into by 100 plus percentage abundance into atomic mass is 57 by 100. Do this. I will do this. Okay. It's 5 4s are 20. You carry 5 5s are 25 plus 27. Okay. 100 plus 90. So 0 here, 9 6 are 4, 5 carry, 9 5 is 45 plus 5, 50. Okay. Okay, by 100 plus, yeah, 5 5 is 7 to 35. 3 carry, 5 5 is 25 plus 3, 28 by 100. Okay, and adding all of them, you get the answer by 100. You need to add here. Okay, you will add here as a rough 270 plus 5040 plus, okay, 285. You have 5. 7 plus 8 is 15 plus 4 18. 1 carry, 1 plus 2, 3 plus 2, 5. 5595 by 5595 by 100 means 5595 by 100 means what? 1 2. Okay, 55.95 is the answer for this question. Just simple. You can do it in 1 minute. Just you need to solve more multiplication, division, so multiplication and addition type of arithmetic operations. That's it. It's a very easy thing. You just copy it down. You can, means I cannot say that exactly. It will be again coming in Jee means, okay, they will ask this, if instead of 5% he may ask 7%, 10%, 50%, like that. The total percentage is always 100. See this. So, take a screenshot, I'll give 5 seconds. Okay, now mole concept. Let us come to. Okay, I forgot to explain this. Okay, it's not much important. If you want, you can skip. It's a simple formula. Okay, what is vapor density of gaseous mixture? Vapor density. Okay, vapor density of gaseous mixture is equals to molecular weight of the molecule by 2. Vapor density of gaseous mixture is equals to molecular weight by 2. And you are getting my point. What is it? Vapor density of gaseous mixture is equals to molecular weight by 2. Okay, this is the formula. No need problems for that. No problem. No, not important. So mole concept. This is very very important. See, number of moles is always represented by letter small n. Right? Number of moles is represented by letter small n. In this mole concept, there is number based on the number of moles, and we have 3 equations. Okay. We have 3 main formulae are, okay, based on this concept, number of moles, we have 3 main formulas. 3 main formulae, okay. First one is number of moles. I already told you number of moles is represented by small n. Number of moles is equals to given mass by molar mass. First formula is number of moles is equals to given mass by molar mass. Number of moles is equals to given mass by molar mass. And second formula is number of moles is equals to given number of particles by Avogadro number. Number of moles is equals to number of particles by divided by Avogadro number. So n is equals to number of moles is equals to given number of particles capital N by Avogadro number. So we can write this formula, number of moles, second formula in shortcut as number of moles n is equals to capital N by small n A. N small n is equals to capital N by n A. Means number of moles is equals to number of particles by Na, means Avogadro number. Okay, Avogadro number, we have fixed number, that is Avogadro number Na is equals to 6.023 into 10 to the power of 23. Okay, the Avogadro number Na is equals to 6.023 into 10 to the power of 23. The second formula in Avogadro number you have is Na is equals to 6.023 into 10 to the power of 23. Repeat it. Avogadro number Na is equals to 6.023 into 10 to the power of 23. Okay, third formula is number of moles is equals to given volume of the gas at HTP by 22.4 liters. Okay, it's liters. L means liter. Okay, number of moles, third formula is number of moles is equals to given volume of gas at STP by 22.4 liters. Okay. Okay, number of moles is equal to given volume of gas by 22.4 liters. Here, given volume of gas at STP in liters. The numerator and denominator should be in liters. Okay, I am getting my point. Okay, the point is that. Okay, the point is that number of moles. Third formula. It's very important. You will be frequently using. You should do in your mind. Number of moles is equal to given number of particles. Given volume of the gas at STP by 22.4 liters. Here STP, you may ask, what is STP? STP means standard temperature and pressure. STP means standard temperature and pressure. Okay, STP means standard temperature and pressure. Standard temperature and pressure. Okay, you need not worry about this. Standard temperature is 25 degrees centigrade Celsius, and pressure is atmospheric pressure, that is 1 atm. So STP means standard temperature and pressure. No need to worry about this, but you need to mention as at the rate of STP. Okay, number of moles is equals to given number of this form, J form. Number of moles is equals to given number of particles by Avogadro number. Small n is equals to capital N by Na. Third formula is given number of moles is equals to given volume at STP of the gas by 22.4 liters. Okay. Well, now this is also important. Percentage of an element in the compound. Okay, percentage of an element in the compound. Okay, first of all, percentage by weight of the element. How much percent of the element is there in the compound? Percentage of an element in the compound means how much percent of the element is there in the compound. Percentage by weight is equals to weight of the element in the given compound, weight of the element in the given compound by molecular weight of the compound into 100. Yeah, you are getting my point. Then percentage of an element in the compound is percentage by weight is equals to given mass of the element in the compound, weight of the element in the given compound by molecular weight into of the compound into 100. You just note down this. I love this. If I tell you, if I give you the example of CaCO3, what is CaCO3? It's calcium carbonate. CaCO3 is calcium carbonate. Tell percentage of calcium in CaCO3. What did I ask? Tell the percentage of the element of calcium in CaCO3. Percentage of formula is percentage of element is percentage of calcium in CaCO3. Percentage of calcium is equals to given weight of the element. How much it is there? So total weight is total weight of element. Total weight of molecule. Total weight of molecule is atomic mass of calcium is 40 plus atomic weight of carbon is 12. Yeah, atomic mass of oxygen is atomic number is 8. Atomic mass 16. 63 is a 40. Okay. 40 by total mass is 40 plus 12, 52 plus 52 plus 48. That's 100. Okay. Percentage of calcium is equals to weight of the element in the compound. How many atoms are there? Only one atom. So percentage of the calcium is equals to weight of calcium in the compound by total weight into 100. How much percentage is there? It's 40%. Okay. Like this you need to do. And again I'll give another question. If I tell in calcium sodium carbonate, how much percentage of sodium is there? Okay, then percentage of sodium is equals to mass, total mass of the compound is, see, atomic number of sodium is, neon, after that sodium, right? Atomic number of sodium is 11. So, but atomic mass is 23. So, two atoms are there. So, 2 into 23 is 46, right? 46 AMU of sodium is there. 46 by total weight is 46 plus carbon is 12 plus oxygen is 316 is 48. Okay, 48 plus 12 is 60 plus 46 is 106. 106 into 100. You do this calculation. Okay, I will do 2 5 is 2 3 is 2 2 is 2 3 is. Okay, approximately if I do, yeah, 2300 by 53. Okay, I will calculate 53. 53 2300 or 53 into 4 5 3 4 3 is 1 4 5 is 20%. 212 is 4 times. It's 18, right? Then it's 2, 18. 180 means we are taking, yeah, okay. We will take 3 times. So 53 into 3. It is 51, 59. So this 21, right? 21. And you need to take point here. So approximately 43.4% is the sodium in this compound. Like this we need to calculate. Okay, like this we need to calculate. The answer is, I written right 43.4. If I tell you correctly, you have 53 into 3, 3 is 9, 3 is 15. So actually we need to take 43.3 is 159 means 51 again, yeah, approximately 43.39 means we can take it as 43.39 is the correct answer. But if you want to round off in your board exam, you can write as 43.4%. But in integer type questions in JEE means you need to write it as 43.39. You may tell if answer is equals to, if answer is equals to, we will not say, if answer is 40, if answer is A, then A into, if answer is A, if answer is A into 10 to the power of, yeah, A into 10, round of A, then A is what? Okay, A is what? In that case, means we got 43, means basically what I am telling you is, if percentage of sodium is A into 10 to the power, A into 10 to the power of 1 means 10, round of A is the answer. Round of A is the answer, which we rounded off value of A is the answer. So here 43.39 get written as 4.399 into 10. Okay, you need to write the value by rounding off in integer type. Okay, you need to tell any integer. Then if 4.3 is close to 4, so you need to write as 04.00, like this you need to write. Not, if you write 4 also, sometimes it will be mistake if there is any error. So it is better to write 04.00. Like this the questions will be. The calculation part, if you have any doubt, I'll just zoom the video. Better you do the calculation as per your understanding. See, if it is not clear, you just comment me down. Yeah, this is just calculation part, that's it. I zoom till maximum how much it is there. Yeah, that's it for this part. Now let us in the next part we'll complete this empirical formula, molecular formula, molality, normality, and stoichiometry. Okay, thank you. Friends, now we are going to see about the solution. What is a solution and the proper definition of the solution. Along with that, we'll start the concentration terms. Okay. Solution. What is a solution definition? Solution is a homogeneous mixture of some components. We cannot say of two components because we have many types of solutions. Okay, solution, it has a definition that solution is a homogeneous mixture of components. Means it has some components. This homogeneous mixture, since solution is homogeneous mixture, this has uniform composition throughout. Okay, as I told you previously, differences between homogeneous and heterogeneous. If you have not visited, you just go to the part 1 of the video for better clarity. This is the part 3 of the video, right? Okay, I'll make a one shot by combining this, but if you want to see as parts, this is the part 3. Now, solution is a homogeneous mixture having uniform composition and it's a mixture of some components. If in a solution there are two components, then it is called as binary solution. If there are three components, it is called as trinary solution. If it has four components, it is quaternary solution. So, since at this level in this 11th class for JEE and NEET and CBSE board exams, we have only two components. So for two components, the solution is called as binary solution. This binary solution has two parts. Okay, binary solution has two parts. So the two components, they are solute and solvent. Solute and solvent. Remember one thing. So we define first we'll understand the definition of solvent. What is solvent? Solvent is a component of binary solution which has physical state same as the physical state of the solution. Suppose we have solvent in liquid state and solution. Okay, for example, for your better understanding, if we have some solution, okay, some sugar solution, okay, if you have sugar solution, okay, in this sugar solution you have sugar plus water, right? What is a sugar solution? Suppose if you will make in home, right, you will drink sugar water. It's nothing but sugar solution. It is nothing but sugar plus water. In this case, sugar is a solute, and water is a solvent. Okay, in this case, in sugar solution, you always observe it in liquid state, right? And sugar is in solid state. Water is in liquid state. So the solution is dominating. So the solvent is dominating the solution. So the solvent is a component of solution which has same physical state as that of solution. Okay, that's it. Suppose in sugar solution you will have water as solvent because the state of water and the solution is same. Both are in liquid state. Okay, if both this is valid when the solute and solvent are in different phase. Okay, but there will be some conditions where solute and solvent both will be having different state, same state. In that case, the component which is present in amount, means more amount is there, that is called as solvent, which is remaining amount, that is small amount of substance component is called as solute. That's it. If both solute and solvent have same physical state. Okay, I hope this you got clarity. Okay, I will draw like this. This is a glass and you have some sugar solution. You added water and sugar. Yeah, just for your understanding, nothing much. No, just copy this down. After this, you will be understanding this concentration terms. This concentration terms you have so many. Okay, first let us understand basically weight by weight percentage, weight by volume percentage, and volume by volume percentage. Now these are concentration terms. Okay, first what is percentage weight by weight? In question he may ask you that percentage weight by weight of NaCl. What do you understand? If you don't understand this, and if they gave in question that this percentage weight by weight of NaCl is there in H2O, example. Okay, suppose percentage of weight by weight of NaCl is in H2O. You should understand like this. But first you learn this, I will tell you this. Okay, for where it is used, I am just telling you the practical application and the questions where you will be getting these situations. You just understand this. We will don't concentrate here. We will understand this by first remembering this formula. Okay, percentage weight by weight represented by percentage W divided by W is nothing but weight of solute divided by weight of solution into 100. Since you are calculating percentage, you should always multiply with 100. That you are learning from your childhood. That is percentage weight by weight is equals to weight of solute by weight of solution into 100. Similarly, percentage W by V, V for volume. So percentage W by V, percentage weight by volume is equals to weight of solute by volume of solution into 100. Right? Percentage W by V is equals to weight of solute by volume of solution into 100. I'll tell you one trick. First you just see what I'm telling. Percentage V by V means percentage volume by volume is nothing but volume of solute by volume of solution into 100. See, you just remember one thing. Whenever you have percentage in the question, you just multiply with 100. That's it. And for all these formulas, okay, I draw one line. This is 100, nothing much. Okay. Yeah. In these cases, I'll conclude with only remembering one type of formula. From this, you can easily derive this. No need to worry. What is that? I'll tell you. See. In all these cases, what you are observing is in percentage weight by weight or percentage weight by volume or percentage volume by volume, you are observing only one thing, that is solute by solution. That's it. Solute by solution. Solute by solution into 100. That's it. You are only observing this thing, nothing much. Okay. In all these cases, you are observing only one thing, that is solute divided by solution into 100. Solute by solution into 100. See, just observe. Solute. Check all the numerators. Solute. Right? Solute. Verified. Now solution. Verified. Okay. Solute by solution. Here also solute by solution into 100. But one thing you need to remember is W stands for weight. V stands for volume. Suppose now if I ask you, you don't need to mug up this. You just understand. If I ask you percentage weight V by percentage W by V, if I ask, what is your answer? Just simply write solute by solution into 100. As I told you here, solute by solution into 100. What they ask? Weight. W means weight. So weight of solute by V means volume. That's volume of solution. That's it. This is a very simple thing. But by only remembering this, you are getting 3 formulas. Okay. It's very easy and simple trick I told you. Now, as per this, from the knowledge you have gained from here, you just remember that. You just see this, understand this. Percentage weight by weight of NaCl in H2O means that if I have 30% of NaCl weight by weight in H2O, if I tell you, it's nothing but 30%, which means It means 30 grams of NaCl in 100 grams of solution into 100. This is the only meaning of it. No need to worry, right? Okay, you just copy it out. I'll write. We'll go to the empirical formula and molecular formula now. Take a screenshot. I am giving you 5 seconds. Now let us start with molarity represented by capital M. Okay, what is it? Molarity. Okay, there's much difference between molarity and molality. Okay, small r here is there means it's molarity represented by capital M. Molality represented by small m. Okay, molarity represented by capital M. Molality represented by small m. Molarity is equals to number of moles of solute by volume of solution in liters. Okay, let us repeat it. Molarity is equals to number of moles of solute by volume of solution in liters. In liters, you must remember it. It's a note point. Okay, if you are given with a solution, mostly if you want to twist the question, he will always give in ml. The examiner who want to set the paper will not think to give directly. He will not give substitution based questions. Like if he give he will not give, if n is not given, volume is given, m is given, so you just substitute. No, not like that. Suppose, see, I am telling you, like if you are 3 ml, 3 molar, if you have 3 molar solution, okay, and moles of solute are not given, and it's given as 4 liter. Number of moles is 3 4s are 12. No. These type of questions you don't expect. Okay, I'm going to tell you about the real case scenario where you will be seeing day-to-day life while solving the problems. Molarity is equals to number of moles of solute by volume of solution in liters. And you know, let us recall the previous formula of number of moles. We have 3 relations related to number of moles. First one is number of moles is equals to given mass by molar mass. Okay, second one is number of moles is equals to given number of particles by Avogadro number. That is nothing but Avogadro number. Third one is number of moles is equals to given volume by 22.4 liter of gas. This is a gas. For gas it is valid at STP, means standard temperature and pressure. Number of moles is equals to given volume by 22.4 liter of the gas. Now, see, this given volume should also be in liters. This denominator should also be in liters. That's the thing. Okay. Now, number of moles can be written in these type of formats. Whatever you can write, anything you can write according to the situation. If you are given with suppose if the number of particles are given, okay, and you need to find the number of moles of solute. Mostly he will ask like that. You will be given with 2 into 10 to the power of 20 particles are there. 2 into 10 to the power of 20 particles of solute you will give. Accordingly, you should derive the number of moles. Like, since you know that Avogadro number Na is nothing but 6.023 into 10 to the power of 23. This is the Avogadro number. Okay, I told you previously, Avogadro number Na is 6.023 into 10 to the power of 23. Okay, let us repeat again. The number of Avogadro number represented by n subscript A, the Na is equals to 6.023 into 10 to the power of 23. This 23 will be there, like that you need to remember. Suppose like this, it is given, so 2 into 10 to the power of 20 particles of solute are there, and given a volume of solution is given. You need to find the molarity, let us say. Then you need to find, you know that number of moles is equals to given number of particles by Avogadro number. Given number of particles is what? 10 into 10 to the power of 20 by 6.023 into 10 to the power of 23. In this case, 20 minus 23 is minus 3 into, in this case you can approximate. If this is an MCQ type of question, you can 6.02 also you can take. then we can cancel with 2, 200 to 3 are 1, right? By 3.01. Like this you need to calculate. You will get multiply and divide by 10. Should do all these operations by multiplying, dividing, adding, subtracting. These are the solving strategies. Okay. Now 10 by 3 is what? Nearly 3.33. 3.33. It is greater, right? So 3.29 like that. It will be answer into 10 to the power of. Okay, I'll write here. Which is just an example, not even example. I'm telling how to solve. Okay. You just consider this. It will be 3.28 something. You just calculate into 10 to the power of 10 to the power of 1. If it goes upside, it is 10 to the power of minus 1. Minus 3 minus 1 is minus 4. These are the number of moles. Okay. From this number of moles, volume, just substitute, you will get molarity. These type of calculations you need to do. In always a question, 2-3 formulas should be are mixed, and you need to do in your mind. Okay. So it's not an example. Don't take it as an example. I'm just telling you how the thing is working. Okay. Remember, this is very important. Most of the questions he will not give. Some people will confuse you. Mostly all will remember 6.023. But what is this? 10 to the power of something they will say. Okay, not like that. You need to this. You need to remember this something only. Okay, it's 23. Right? Now, yeah. In this case, this is some competitive exam level. This is board level. This is board level. This and this also board level. Now I am going to tell you about the competitive exams like Jee, NEET, IIT. For these exams, okay, molarity. In this you have to analyze more. You need to analyze, and not only this, you will be having most of the concepts linked. This is a first type of model where the questions will be lifted. Okay. The molarity is equals to number of moles of solute, right? Just for example, I am taking given number of moles as given mass by molar mass. From this I am taking. I am writing as number of moles of solute as given mass of solute by molar mass of solute by volume of solution in liters. That's what I told you. Sometimes you will be given volume in ml, that is milliliters. Mostly in ml only you will be given. In that case, you need to write volume in ml. Whatever, suppose some 50 ml it is given. If you have, suppose 50 ml, if you have 50 ml, you need to write as, you need to divide the volume in ml with 1000, so that you are converting this ml, 50 ml into liters. Okay. In this case, you are doing like this. If you have numerator denominator by numerator denominator, in this case, you know basic maths, right? So you just write like this, and this will be the reciprocal. 1000 will be going upside, and volume in ml will come down. So this is the formula of molarity, and in high level questions. Okay, this given mass of solute, molar mass of solute, this you can replace with number of moles only. N into 1000. Okay, this is simplified way I'll give. Molarity is equals to, since you know that these three formulas, you can replace any of them according to the situation. Molarity is equals to mass of solute, that is number of moles, that is represented by small n, into 1000 by volume in ml. See, this is a direct formula where you will not find in NCERT also, or even any books, competitive exam books. So all will focus on problems, but nobody focus on theory more. Okay, I'm just emphasizing on the theory. Since see, in this chapter, about I can say 30 to 40% questions in your competitive exams will be asked from this molarity and molarity only. They will just link one topic with another and give you. Okay, I am telling 30 to 40% direct questions. In all the questions you will be linking. Approximately 90% of the questions you will be questions will be related with molarity and molarity. Okay, so that's why I am emphasizing this more. Okay, just similarly, this is the story of molarity represented by capital M. Now I am going to tell you about the molality. What is it? Molality. That is R. This is L. Instead of replace R with L, that is molality. Molality represented by small m. The formula of molality is molality small m is equals to number of moles of solute by mass of solvent in kg. Let us repeat it. Molality is equals to number of moles of solute by mass of solvent in kg. Similarly, this you can write as molarity. Okay, I am writing here similar to that. Moles by number of moles of solute by mass of solvent. Suppose you will be given here in grams. Suppose most of the questions I am telling you for JEE and NEET level, similar to that. It is similar to that I am telling you. Similar to molarity, here molarity also you will be having. Molarity is equals to, let us take given mass by molar mass. Similarly, given mass by molar mass by mass of solvent in kg. In kg, if you are given in grams, then mass in grams by 1000. The same thing, okay? Or you write N by mass by 1000, that is into 1000 by mass. Same thing, the same thing. You will be having the same thing, but instead of this is the final conclusion. This is the derivation. If you have good analysis, you have good analytical strategy, then you can directly do in your mind. Or if you are like I can remember the formula, but I cannot derive in 1-2 minutes. In that case, to remember the formulas. These are also the derived formulas. Along with this, you remember these formulas also. These are final formulas. Okay. Final formulae. Okay. This will write N into 1000 by mass in grams of salt. See, okay, since it is not visible here, I'll continue here. I'll erase this. You just take a screenshot of this. Yeah, I'll be erasing in 5 seconds. Yeah. If you have any doubt, you just comment. You are free to ask doubts. Okay. Even previously I used to suffer, but since I don't have proper guidance. Okay. You just I have guidance, but there is no one to explain each and everything. Okay. I only used to understand research on the topic more. Like I used to swim in that topic, and now I am telling you. So these are the conclusions which I got when I prepared for JEE and my state competitive exam. My state competitive exam is TSMZ. Okay, I prepared for that. And similar to that COMEDK, whatever you did, this similar to WBJE in West Bengal. So state competitive exam. If you first learn for JEE, you will be easily cracking the state competitive exam. Okay, aim for the big. Okay, if you don't, you will at least go to the state colleges which are in top. Okay. I am analyzing this. I already told you previously. Okay, if you didn't write, you just rewind the video. Okay. Okay. I think this is visible to you. Okay. Now this is for molarity. Now I am going to write the same final formula for molarity. What is small m? Small m represents molarity. Molarity small m is equals to, similar. See, if you remember one thing, instead of this is volume in ml of solution. Okay, of solution. Okay, of solution. Okay, this is molarity is equals to n into 1000 by volume in ml of solution. But here n into 1000 by mass of solvent. This is of solution. Molarity is for solution. Molarity is for solvent in grams. Okay, this is the final formula of this. These are very, very important. For at this stage you may think, no, what happens if I skip this topic? It is very difficult. No. If you skip, it is like you are skipping the whole concept. I can understand this is a difficult topic, but you will be scoring much if you get some easy questions, or if you understand the stoichiometry, you can also understand this molarity. You just follow my video, you will be definitely understanding the topic. Okay, you just write this down. We will go to empirical formula and molecular formula. Just copy it. One. Now we are going to see about the two important topics. These are subtopics. That is empirical formula represented by EF and molecular formula MF. Okay, first thing we are going to see is empirical formula. Okay, empirical formula is nothing but it is a formula in simplest whole number ratio. Okay, it is a formula in simplest whole number ratio. What is whole number? I am just asking you the simple question. What is the whole number? Whole number is a number which whole numbers are the numbers which starts from 0 to till infinity. Okay, it includes all the positive integers along with 0, that are whole numbers. Okay, not natural numbers which starts from 1 to infinity. Okay, positive infinity. Now empirical formula is nothing but a formula in simplest whole number ratio. Okay, let us see one example. See, for glucose, you heard about the glucose in your class 10. Okay, for glucose, that is formula of glucose is C6H12O6. For C6H12O6, what is EF? Means for glucose C6H12O6, what is the empirical formula? Okay, empirical formula of C6H12O6 is, you just, in this case, you just write down the numbers of number of atoms present as ratio. See, empirical formula is simplest whole number ratio. You just write like this: C6H12O6. 6 carbon has 6 atoms, hydrogen has 12 atoms, oxygen has 6 atoms. So 6 is to 12 is to 6. All can be cancelled with 6 table, right? 6 1s are 6, 6 2s are 12, and 6 1 are 6. 1 is to 2 is to 1 ratio it is there. So it's C1H2O1. Instead of writing 1, you can just mention normally. Okay. So it's a CH2O. CH2O is the empirical formula of the glucose. See, remember one thing. I need to tell you one note point that you just write down in your notes. Okay. Empirical formula of any empirical formula can be many. Means same empirical formula will be for multiple organic compounds or any compounds. Okay. Means empirical formula of will be same. Empirical formula will be same for 2 or more than 2 molecular formulas. Okay. Okay. If I tell you simply what it is, the empirical formula. Suppose CH2O is there. This CH2O can be the empirical formula of any other molecule other than glucose. Okay. It can be for some other also. means you can have two or three more molecules having the same empirical formula. That's the thing I want to convey you. Okay, there will be same empirical formula for different molecules, but molecular formula will be rare. Means for sucrose and glucose it will be different. For sucrose is C12H22O11. Okay, for that, and glucose C6H12O6. The molecular formula MF will be different. So molecular formula is nothing but this is the formula which is the actual formula of molecule. Okay, the molecular formula is nothing but it's the actual formula of the molecule. Means without changing any number of atoms in the molecule and the individual elements also, there will be same atoms. There will be no change. Whatever will be the formula of the compound, that is only called as molecular formula. Simplest form, if you are writing that same formula of molecular formula, if you are writing the molecular formula in terms of simple whole number ratio, it is empirical formula. Means empirical formula is a type of molecular formula, but molecular formula is not a type of empirical formula. Okay, means there will be more than one compounds having same empirical formula, but molecular formula should be different. The molecular formula is unique, but empirical formula can be same for any number of molecules, any number of compounds. Okay, this is the thing. And the relation between empirical formula and molecular formula is, see, N is equals to, N means here not number of moles, it's the ratio by which it's the factor, N is the factor by which molecular formula and empirical formula are different. If you see C6H12O6, after writing it in simple whole number ratio, it is becoming CH2O. Here what is the factor? 6 is the factor. You are cancelling with 6 all the numbers, right? So 6 is the factor. If you multiply with 6 all the elements, you will be getting the same formula. So 6 is the factor. It's factor, not number of moles. If you confuse, you can also represent with X or Y something, some other variable. Okay. So N is equals to, factor is equals to molecular formula mass by empirical formula mass. Okay, let us repeat it for 3 times. Number of factor which differs both empirical formula and molecular formula is N is equals to molecular formula mass by empirical formula mass. N is equals to, factor is equals to molecular formula mass by empirical formula mass. Okay, suppose you have some molecular formula. You can write it as empirical formula of N taken n times. Molecular formula is equals to empirical formula taken n times. I am taking the same example for you can easily understand. If I take some 3-4 examples, you will be confusing. For understanding this element only, it's a difficult thing. Since you came recently from 10th grade, okay. Now, then you only heard about the calcium carbonate or quick lime, the only basic glucose. You might have only these limited elements, limited compounds. But since you are entered in 11th grade recently, I am just catching one easy compound and explaining to you the whole thing, whole story behind it. Okay, molecular formula is equals to empirical formula taken n times. Suppose molecular formula is here glucose, C6H12O6, can be written as C6H12O6 is equals to CH2O, which we have obtained the empirical formula taken 6 times. If you multiply, what it will be? C6, 2 6 are 12, and 6 1 is 6, C6H12O6. This is the relation between them. Okay. Suppose you want to calculate the formula mass. Okay, directly you can calculate. So instead of this, you can calculate the mass also. But you can calculate factor by mass also, like this. Suppose so what's the mass of this C6H12O6 is 6 into what's the AMU, atomic mass unit. I will be telling you about the AMU. How many kgs it is? 6 into the carbon has atomic number of carbon is what 6, right? Now 6 to the 12 is the atomic mass, plus 12 hydrogen has mass 1, plus 6 into atomic mass of oxygen is 16. So 12 6 are 72 plus 12 plus 16 6 is what? 16 6 is 96. Okay. 16 5 are 80, 16 6 are 96. 2 plus 2 4, so 84 plus 96 is 180. It will be 180. The molecular formula of C6H12O6 is 180. 6 plus 4 10, 1 carry, 9 plus 1 10, 80. I remember directly, but for your basic understanding, I am writing it for you. Okay, n is equals to 180 divided by, what's the empirical formula of CH2O? Right? CH2O has 12 plus 2 plus 16, that is 12 plus 2 is 14 plus 16 is 30. 0 0 cancel, 3 1s are 3 6 are. Here from the mass also you can obtain the factor. Okay, whatever we did you can obtain directly or by mass also. If you don't know anything how to compare anything, if you are good at remembering formula, you can derive from the mass also. Okay, just note down. I'll give you 10 seconds, you just note down. Next we'll go to the another topic called as stoichiometry. Okay, before this after this I'll explain n factor, which is easy topic. N factor basics you will be learning whole in depth in redox reaction chapter, but let us see the normality and n factor after this. Note down. Now let us see the n factor or valence factor. N factor or valence factor. Okay, you will be having in this you will be having three cases. First one is n factor of ions. Second one is n factor of acids. Third one is n factor of bases. So let us see the n factor or valence factor of ions. For n factor of ions will be the charge. N factor of ions is the charge on cation. See this. Okay. First one is n factor of ions is charge on cation. Whatever the charge which is present on cation, that is only the n factor of ions. N factor of ions is charge on cation. Suppose you have NaCl. NaCl can be split as Na plus Cl minus. You might have heard this previously. NaCl can be written as Na plus Cl minus. So what is the charge on cation? Plus means plus 1. Plus 1 is the charge on cation. So n factor of NaCl is 1. Similarly, in AlCl3, what is AlCl3? Aluminum chloride. Aluminum chloride AlCl3 can be split as Al3 plus, see, crisscross method. I tell you, AlCl3, what happens is, here, it will be like this, right? Okay, I'll give you one formula for this also. You should be a pro in when you come to this equilibrium chapter, the balancing of the equation in ions. Okay, let us see. For example, I'll tell you later. AlCl3, that is aluminum chloride upon ionization. AlCl3 gives Al3 plus 3Cl minus. Okay, Al3 plus 3Cl minus. What is the charge? In fact, is the charge on cation, right? So, what is the charge? 3. So, the n factor of AlCl3 is 3. N factor is 3, here n factor is 1. Now, n factor of acids. Okay, n factor of acids, you will be having n factor of acids is nothing but the basicity. What is the basicity if you ask? We don't want the actual definition of basicity. Actual definition of basicity, see, I am going to tell you, but no need to note it, it's not for our use. Okay, basicity is nothing but the number of H plus ions removed from the solution. Okay, basicity is nothing but the number of H plus ions removed from the solution. So it has a big story, but there is no use. Nowhere asks the solution, nowhere asks the question, and nowhere asks the MCQ. That's my guarantee. Okay, so this is a basicity. You need to understand the basicity, that is n factor of acids. N factor of acids is nothing but the basicity. For acids you will be having basicity. For bases you will be having acidity. It's reverse. For n factor of acids you will be having basicity. These are the exceptions. Except these, for all of them, the number of hydrogens is n factor. I'll be telling one trick. I'll make one YouTube short where I'll be telling one trick where for exceptions. You just subscribe my channel, like it, right? Okay. I'll be telling what's the trick behind these exceptions, and I'll tell you the easy way formula to remember these exceptions. And you also have some another asset where which will be written as base. I'll also explain there in the short. You just go to the short. I'll mention the link in the description, right? Okay, or you just go to the short section after completing this video. This will be like an exercise for you. Okay, so n factor of acids is nothing but the basicity. In general, the n factor of acids will be the number of hydrogen atoms. In general, if you leave the exceptions, n factor of acids is number of hydrogens only. Suppose HCl is there, n factor is 1. H2SO4 is there, that is sulfuric acid. N factor will be number of hydrogens up to, so n factor is 2. But if you see these exceptions, so I will be explaining in your YouTube short. So exceptions, that is H3PO2, you will be having n factor as 1. For H3PO3, n factor is 2. For H3PO4, n factor is 3. I will tell you one trick there, and along with that, I'll in YouTube short I will tell you the one acid which is written as base sometimes to confuse you. So this is the story of acids. Okay, if I give you H2CO3, let us say H2CO3, okay, carbonic acid, H2CO3. Here also the n factor will be 2, the number of hydrogens. Let us take one another acid. Yeah, HNO3, nitric acid. If you take HNO3, here also we have one hydrogen, so n factor is 1 in all the cases, but if you have exceptions, you need to remember them. I will tell you the trick in short. Now third one, you will be having the n factor, that is n factor of bases. N factor of bases. In bases you have simple trick. N factor of bases is nothing but acidity. For acids it's basicity, for bases it is acidity. So n factor of bases will be nothing but number of OH ions present in the solutions. Number of OH atoms present in the solution. So n factor of base is nothing but number of OH present. So suppose you have, see here you have no exceptions. Like in acids, we have phosphorus, phosphoric and phosphorus acid. You have no exceptions here. Here n factor of bases you will be having number of OH will be OH atoms will be the n factor. So in AOH you will be having, since only you have one molecule of OH, so n factor is 1. Here you have in Al OH taken place, aluminum hydroxide, 3 is the n factor. In KOH 1, COOH taken twice, that is it's a slate to line. Here you will be having 2 as n factor. Okay. And if you come to the normality, n means normality. In normality you will have very less questions. You will be only asked with the formula or some basic questions. No, that's it. 99% no questions. 1% if they ask, that too only definitions in board exams. Normality. Okay. Normality is nothing but represented by capital N. Normality is represented by capital N is equals to gram equivalent of solute by volume of solution in liter. So normality is equals to gram equivalent of solute by volume of solution in liters. You have another formula for normality, that is normality is equals to molarity into n factor. Normality is equals to gram equivalent of solute by volume of solution in liter. And also another formula is normality is equals to molarity into n factor. So normality is equals to molarity, capital N is molarity into n factor. Normality is equals to molarity into n factor. Okay. This is a mostly asked question. This is the derived formula. In some competitive exams, you will be given state competitive exams. Okay, you will be having only M. You will be given M, and you will be asked to calculate molarity, normality. Okay. See, you should compare this normality with molarity, because the denominator in the formula of normality and molarity you have one similarity. You just recognize what it is. In the denominator, molarity is number of moles of solute by volume of solution in liters. Here, normality is gram equivalent of solute by volume of solution in liters. So both have denominator same, that is volume of solution in liters. Right? That's no similarity there. And the gram equivalent weight is nothing but molecular weight by n factor. What is equivalent weight? gram equivalent weight is equals to molecular weight or molar mass of the compound by n factor. Gram equivalent weight is equals to molecular weight by n factor. N factor you can calculate as comes as per this knowledge. Okay. Okay, we just copy this down. Okay, we'll continue then. Friends, now let us see the topic called as stoichiometry. The stoichiometry is basically a calculation part in our chapter. In this, some basic concepts of chemistry, we need to do some calculations such that we need to get the required amount of substance as per the given condition. We'll see what is going on behind this. Okay, basically in this stoichiometry you will be given the amount of substance or you can say any like mass, volume, number of moles of the some other element or molecule, and you will be asked to find for other molecule, and which is only possible when you know the reaction and what are the steps to be followed. Okay, now let us see the stoichiometry. In stoichiometry, to do some calculation, you need to follow some steps. Okay, the steps: write the balanced chemical equation. Okay, first you need to write balanced chemical reaction. After writing the balanced chemical reaction, okay, note down the molar ratio of reactants and products. You need to note down the molar ratio of reactants and products. Means you will be given with some reaction, and for that reaction you need to write a balanced chemical reaction. Okay, so for a given reaction you need to write a balanced chemical reaction. What is a balanced chemical reaction mean? Balanced chemical reaction is that the number of reactants must be same as the number of products, right? Suppose on the left hand side you have 2 moles of nitrogen, right? Similarly, according to the law of conservation of mass, the atom can neither be created nor be destroyed. So according to that, mass cannot be created, neither be destroyed. Okay, so the number of nitrogens on the reactants is 2. So you should in the products also you have only 2 moles of nitrogen. Similarly, therefore that's the meaning of balanced chemical reaction. You might have learned in your earlier classes, but still I am telling from the scratch. Okay, it's so that everybody is clear with the topic. Okay, write a balanced chemical reaction of the given reaction. Then note down the molar ratio of reactants and products. You need to write the molar ratio of reactants and products. Means for a given reaction you need to write molar ratio. What does molar ratio mean? Means for the given balanced equation you need to write the step is that first you need to write all the moles below the molecule, and after that you need to keep the ratio symbol which you will keep. Okay, like this, the column like this is the symbol of ratio, right? So you will be keeping like this. Suppose if you take one reaction, N2 plus H2 gives NH3. I'll tell you the example, but these are the steps. In the steps I am explaining what is going on behind this. That is the only thing I want to explain. Okay, N2 plus H2 gives NH3. If you balance this, you have 2 moles here. So 2 3 is 6, 2 3 is 6. So this 3 2 is 6. It's balanced. Okay. Now what does molar ratio mean there? Note down the molar ratio of reactants and products. First, how many moles are there here? 1. You just write down below the molecule which is present here. Here 3 are there. First you write like this. And this is the molar ratio. This is the only molar ratio. Means 1 mole of nitrogen is reacting with 3 moles of H2. 3 moles of H2 to give 2 moles of NH3. Are you getting my point? 1 mole of see this. You just see this. Don't see this. Only 1 mole of N2 nitrogen is reacting with 3 moles of H2 to produce 2 moles of NH3. This is the meaning of molar ratio. It's just a number separated by this column. This is ratio. That's it. Just see. Don't note this down. I'll give you one example. And as per this steps, I'll solve the question and we'll make our concept clear, right? So note down the molar ratio of reactants and products, what we have did previously. Now convert the moles into desired parameters such as mass, volume, and number of particles. Convert moles into desired parameters such as mass, volume, and number of particles. Since we know that we have three formulas of moles, right? Number of moles has three forms. First one is number of moles is equals to given mass by molar mass. Number of moles is equals to given volume by 22.4 liter at standard temperature and pressure. And third one is number of moles is equals to given number of particles by Avogadro number. In these three formulas, you will be linked moles with mass, volume, and number of particles. These three are the parameters here. So since moles have linked with these three parameters, you can convert moles into any of them. That's the only meaning here. Okay. You can convert moles into desired parameters such as mass, volume, number of particles. Because you have a direct formula based on this. So you can convert as per your wish. And fourth point is observe the chemical change of required atom or molecule and perform operations to get result. What does it mean? Observe the chemical change of required atom or molecule and perform operations to get result. Means that you need to observe the change which is happening for the given atom or molecule, and you need to perform some operations. Means operation means arithmetic calculations to get the result. And what are that arithmetic operations? I am going to tell you in this next part of the video, where I will discuss the question. Let us first deal with this and we will do the question for our better clarity. Okay. Now I am just giving you a mind map for your better understanding that the moles can be converted into mass, volume, and number of particles, and vice versa. Because from number of particles you can get moles, and from that you can get volume. Suppose if you know volume and you want to get number of particles, you can convert them first into moles and then into number of particles. That's it. It's a simple thing. This is only the thing which you have applied where you have learned it previously. You are applying the thing, you are applying your knowledge, previous knowledge, and naming as a stoichiometry, and that's it. Nothing more than that. Okay. You just note down this. We have some other point to be noted, and after that we will discuss the example. Okay. You just take a screenshot. I'll erase this. Okay, so that we can discuss the next point, right? See, now we are going to discuss the fifth point, that is use unitary method to obtain the result. What does it mean? Use unitary method to obtain the result. Means you need to use the unitary method to get the result. What is the result here? The result is nothing but the amount of substance, that is the either the number of moles on given volume or mass or number of particles. You can obtain those for the given element or molecule. That's the result mean. Okay, means in this I already told you that in this stoichiometry you will be given the amount of some other parameter for the other element, and you need to find for the other element or other molecule by using that information. Means you need to perform calculation for one thing by knowing the other thing. That's it. Okay, I'll tell you the example, don't worry. Okay. We use the unitary method to obtain result. You need to use the unitary method. What's the unitary method? You just see. Unitary method is nothing but, suppose in our general case, if you go to some market, okay, and fruit market, and you want to buy some 5 apples, okay, these 5 apples cost some 40 rupees, let us say. Okay, 5 apples cost 40 rupees, and you want to calculate for 7 apples. Okay, are you understanding my point? If you go to the fruit market and 5 apples cost some 40 rupees, and you want for 7 apples, what's the cost? Now, the unitary method, the name itself states that unitary. Uni means what? 1. You are calculating for 1 apple. After that, from 5 apples, you need to convert into 1 apple cost. 1 apple cost. After that, you need to multiply with the number of apples. Okay, you just understand the logic, not what I am doing. It's simple mathematics. I know most of the people know, but the name of the unitary method may be confusing for you. Okay, so 5 apples, cost of 1 apple. Cost of 1 apple is what? 40 rupees for 5 apples. So what is 1 apple cost? 40 by 5. Right? 5 ones are 5 eights are 40. So cost of 1 apple is, cost of each apple is 5 eights are 40 rupees. Okay, 40 rupees. This is the cost of 1 apple. Now, what's the cost of 7 apples? 7 apples is 8 into 7. 8 sevens are 56 rupees. This is the cost of 7 apples. Did you understand what is unitary method? This unitary method is nothing but if you know the amount of substance for n moles. Suppose you know the amount of substance, the weight for 5 moles, and you want to calculate for 7 moles. You should use this, and that's it. Okay, you just note this down, and if you have some doubt, you just note this example also. Okay, after that we'll proceed to the example. If you have any doubt, you just comment me down, and if you are facing any issue, you just comment me down. Mostly, I hope it is very clear for you since I am explaining it in a very basic manner. Okay. And if you are unable to write and it's taking a lot of time, you just take a screenshot and take it as Xerox. Okay, so that it will be saving your time. You just take the Xerox, or if you want the PDF or PDF as a PPT, then I'll share you in the comment box. Okay, if you want, you just comment me down that I want the notes of this chapter. I'll just send you. Okay, don't worry. Now let us see this example. This is not the exact example I want to tell you. So since it's your first question based on the stoichiometry, so let us first understand how the number of molecules or moles or mass or volume is being converted from reactant towards products. How it is changing, and we'll see this. Okay, I'm just taking the basic example. Okay, this is a basic word, basic. We are taking the basic example that CH4 plus O2 gives CO2 plus H2O. This is an organic reaction. Which reaction is this? You just comment me down so that I can know that you are listening this class properly with a great interest. So I'll just read out this reaction again. CH4 plus O2 gives CO2 plus H2O. CO2 plus H2O. Okay. What's the first step? You just balance the reaction. Any reaction given to you in the stoichiometry, you just balance it down. Okay. Let us check for carbons. How many are there? Hydrogens and oxygens. Reactants, products. In carbon, we have 1. Product also 1. Hydrogens 4. Here we have 2. In oxygens, here we have 2, and here also we have 2. Means what we should balance now? We should balance hydrogens. We just multiply with 2. 2 2s are 4. So 2 we need to multiply. What it becomes? 2 2s are 4. 2 2s are 4, and 2 1s are 2 plus 2, 4. Oxygen becomes 4 here. Okay, in product side, oxygen becomes 4, and okay, you need to make the oxygen in the reactant also 4. So you just multiply with this 2. So it becomes 2 2s are 4. It is balanced rate. Number of carbons are 1. RH products also 1, and hydrogens 4. here and here also 2 2s are 4, oxygens 2 2s are 4, and 2 plus 2 4. Yeah, it's just balanced reaction. If you want, so this is the method you might have learned in your 10th grade. This is the method to follow to balance reaction. If you have a good experience, then you can do it mentally only without keeping a pen on paper. That's just, you should always think in such a way that you should always be able to do some 4 or 5 steps in your mind, so that the calculation will become very fast. Okay. Now you just understand what is this, what is the thing going behind this. 1 mole of, I'll write the point, it is 1 point, 1 mole of CH4 reacts with 2 moles of O2 to give what? 1 mole is there, right? Anything is not mentioned behind as a prefix for CO2, then it's 1 mole of CO2 and 2 moles of water, that is H2O. Okay, now what did you understand from this? If nothing is there, it is 1. Okay, first thing is that I am trying to compare the parameter, that is moles. I am trying to compare the moles parameter. Okay, if you talk this reaction in terms of moles, how you can read this reaction? 1 mole of CH4, that is 1 mole of methane, 1 mole of CH4 when reacts with 2 moles of oxygen to give, that is to produce 1 mole of carbon dioxide and 2 moles of water. This is how you can read in terms of moles. If you read in terms of molecules, it is also the same. 1 molecule of CH4 reacts with, I'll write like this, so we can complete this part very faster and go to the real example. Okay, with 2 molecules, it's not moles, we are talking about molecules, in terms of molecules. In molecules of O2 to give 1 molecule of CO2 and 2 molecules of water. If you talk in terms of molecules, and if you talk in terms of mass, you just see. I need to explain this clearly. What is the mass of CH4? CH4 mass is CH4, that is carbon mass is 12 plus 4 ones are 4, that is 16 plus 4, sorry, 12 plus 4 is 16. So mass of CH4 16 means 16 grams of, you need to, I already told, right, in this chapter you need to mention in AMU, atomic mass unit, but you should replace it with grams, since it is gram molecular weight or gram atomic weight. You should always mention in grams. In questions also you will get in grams, so you just replace AMU with grams, that's it. So 16 grams of CH4 when reacts with, I'll write clearly, reacts with what's the mass of oxygen? O2 mass is 2 into 16, that is 16 to 32. We have 2 moles of O2, that is 2 into 32, that is 2 for 2 O2. What's the mass? 2 into 32, 2 to the 4, 2 to the 6, 64 grams. Reacts with 64 grams of O2. Okay, oxygen will write, okay, not O2. Because if you write 64 grams of O2, it becomes 128. It's not the correct way. So, oxygen to give what? Carbon dioxide mass is what? CO2, that is 12 plus 16 to 32, that is 2 plus 2. For 44 grams, to give 44 grams of CO2, and we have 2 moles of water. Water mass is the what? You just remember some standard masses of the regular molecules, like water. Water mass is what? 18. Glucose mass is 180. You should remember like that. Okay. H2SO4 mass is 98. Like that you should recall. You can easily remember. Once you do for 5-6 times, you will encounter all these problems for 5-6 times, more than 5-6 times. You can directly remember the mass. No need to do at all. Just remember. Remembering is a best way in chemistry, since you can save your time. Okay, if you even save 1 minute, it will make a lot of change for you. Okay. Now H2O mass, for you I am calculating, I know the mass, it's 18, 2 plus 16, it is 18, okay, to give, and 18 means that is 1 mole, we have 2 moles, right, 2 into 18, 18 2s are what, 36 grams of H2O, okay, 36 grams of H2O, okay, we can write here O2, no problem. There's nothing like that, just we can just write like this. Okay, you just understand this. Okay, we can also write, first you note down this, I'll write the other thing. Okay. You just take a screenshot, I'll give you some 5 seconds. Now let us see one question, okay? How many grams of O2 is needed to completely react with 0.200 gram of H2 to yield water H2O? Also calculate amount of water formed. Let us read it again, right? How many grams of O2 oxygen is needed to completely react with 0.200 gram of H2 to yield water H2O? Also calculate amount of water formed. Basically, we need to find the amount of oxygen. Okay, we should find the oxygen if it completely reacts with 0.2 gram of H2 to give water. Means this O2 and H2 gives water. This is the reaction we need to understand here. Okay, let us write the reaction. H2 plus O2 gives H2O. Now 1:1. Is this the molar ratio? No, not at all. You just missed one point. That is, we need to balance the reaction before performing the stoichiometric calculations. So, according to that, we have two hydrogens here. But 2 oxygen, 1 oxygen only. You need to balance 2. Right. So 2 oxygens. 2 oxygens. To do the 4, and you need to balance it. Now 4, 2, 2. It's balanced. Okay. Now after that you need to write the molar ratio. So 2 moles, 1 mole, and this is also 2 moles. Means what it is happening here is, now since their given parameter is mass, you need to convert this into mass. Okay. So you just calculate what is the H2 mass is. 2 ones are 2 and 2 2s are 4. 2 into 2, that is 4. 4 mass, 4 grams. Yeah, you just write the mass below. Since we are converting this into mass parameter, since we have already learned that we can convert the moles, into any of the parameters such as mass, volume, and number of particles. So according to that, we can write 4 grams of H2, and this is 16 is the atomic mass of oxygen. So 16 2s are 32 grams, and this is for water. It's 18, right? So 18 2s are 36 grams. This is the ratio of mass. So for 4 grams, see, first understand the question. How many grams of oxygen O2 is needed to completely react with this much amount of H2? Means how much grams of O2 is needed if the 0.2 grams of H2 reacts with this? Means you are doing comparison between hydrogen H2 and oxygen O2. Okay, according to this, you just consider the given reaction. From this, you do unitary method. You just calculate like that. Okay, 4 moles, 4 grams of H2. In the real reaction, what is happening in that 4 grams of H2 reacts with 32 grams of H2O2, right? Means if it completely reacts, then 4 grams of H2 gives 32 grams of O2. Then according to that, how many grams of H2? 0.200. What does 0.200 mean? 0.2 grams gives X, that we don't know how much amount of oxygen is giving. Okay, we do cross multiplication. 4x gives 4x, yeah, it's an equation. So 4x is equals to 32 into 0.2 is nothing but 2 by 10. Now 4 ones are 4 8s are 32. Now x is equals to 8 2s are what? 8 2s are 16 by 10, that is 1.6 grams. Now 1.6 grams, now yeah, I'll write it clearly. 1.6 grams is the amount of O2 that is needed, right? Amount of O2. If you want for, yeah, if you want, yeah, is it visible? Okay, I'll just move it down a little bit. Yeah, I think you can clearly see this now. Okay, the amount of O2 is 1.6. The amount of O2, it's O2, okay, it's O2 oxygen is this much. And is it visible if I write here? Yeah, okay. Now for water, similar comparison you do with water. 4 grams of H2 gives, yeah, if you don't want to compare with H2, you want to compare with oxygen, that's very good. It's your wish, you can do anything, right? Here 32 grams of O2 is giving 36 grams of water, means, okay, then 1.6 of grams of oxygen is giving how much amount of water? Just cross multiply. 32x is equals to 36 into 6 by 10, 16 by 10. You just do, yeah, 4 table, 4, yeah, 4 8s are 32, 4 9s are 36, and 8 1s are 8 2s are, 9 2s are 18, 18 by 10 is 1.8, 1.8 grams of H2. This is the 1.8 grams of H2 you are getting. That's the, hence problem is solved. Okay, let us see another problem. So you'll get better clarity. See, the problem, the much we do the problems, we get that much clarity. Okay, it's not only here in mathematics, physics, wherever you go, the problems, as much as you do, that much knowledge you gain, and it's very different from what others tell. If I tell you something, if I tell you some trick, okay, you'll remember the trick and it is valid for some of the problems. But if you understand properly and listen my trick, it's a double advantage for you. Okay, means first of all you need to be conceptually clear. If you know all the concepts perfectly, whatever I am telling, after that if you go to problems, some people will directly attack on problems. What will they know? They just again see the book, copy the formula and apply the logic. You know what is there that anybody can see and do? Not like that. If you even know, without knowing the formula, you cannot do anything. And if you even see the formula, you should know what is going behind this. Right? Okay, let's see. Yeah, okay, I'll do a little bit down. Okay, it's visible, clearly visible now. You just see this. I know this video is becoming some lengthy. It's not that much lengthy. Okay, it's not some 5-6 hours. I'm just keeping this some basic concepts of chemistry, some 3.5 hours, that's it. Okay, I didn't see the length of the video. You just check it out. If you have any doubt, you just comment me down. Okay, not only this, if you just subscribe my channel, you will get a good advantage. I'll tell all the chapters and I'll clear all your doubts. If this is and if I get a good feedback, I'll also continue with physics. Take a screenshot. Okay, I'll go to the next question. We'll not make much late. You need to brush up on the concept, brush up on the basics. Nothing much like that. Okay. What you should do is, if I tell you one concept, you just pause the video till there. Okay. So suppose the concept is some 25 minutes is their concept. you just read the concept, which I am giving the notes. After reading that, and if you have any doubt, you just rewind the video and see again. And if you still have doubt, you just comment me down. Okay. I guess most of your doubts will be cleared, since I already know what type of doubts will be created in the students. Okay. Some 25 minutes concept is there. You listen my video, you written the notes, then you just go through the notes and do the examples after that. If you just listen and directly do the problem example I am giving, you may confuse, because only listening you don't get. You should also read by after immediately. You should read after I tell. Okay, because if you read, if you start reading, it will take some 1 week in this chapter. If you listen and then read, it will take some 3 days, 2 days only. Okay. Now, before going to before we do the question, I'll tell you some other topic related to the stoichiometry only. That is limiting reagent. Okay, that is limiting reagent. Limiting reagent. What is limiting reagent? It is a reactant. The reactant. This is the reactant. It is the reactant which completes in reaction first, which completes in reaction first is called limiting reagent. Okay, this limiting reagent is represented by LR. You just see limiting reagent is represented by LR. Okay, what it is? Limiting reagent is represented by LR. Limiting reagent is represented by LR. What is limiting reagent? Limiting reagent is nothing but the reactant which completes in the reaction first is called as limiting reagent. What is limiting reagent? Limiting reagent is the reactant which completes in the reaction first. Means it is a reactant which completes early in a reaction is called limiting reagent. Okay. Suppose if we take one example, the famous example, there is N2 plus H2 gives NH3. N2 plus H2 gives NH3. If you take this, then always this is the process called as Haber's process. N2 plus 3H2 gives 2NH3. This is the ratio 1:10. 1 mole of N2 combines with 3 moles of H2 gives 2 moles of NH3. This process, balancing process, is only called as Haber's process. This to form ammonia, you will see in the P block elements where the Haber's process is used for the preparation of ammonia. Okay, N2 plus 3H2 gives NH3. See the balancing. 3 2 is 6. 3 is 6. N2 2. Yeah, it's balanced completely. Now let us see limiting reagent, right? So okay, if I tell see what is the molar ratio? You see 1:2. This is 3. 1:3 is the 1:3 is the molar ratio of N2 and H2. Now, if I say, if I give you some 2 moles of N2 and 9 moles of H2, this is an example given in your NCERT only. We just see 2 moles of N2 and 9 moles of H2. You are given, and you are forming the NH3 using this, which will complete first in the reaction. Means which is going to complete in the reaction first. Which is going to complete in the reaction first is called as limiting reagent, right? So which is limiting reagent? Which is going to complete fast in this reaction? Let us see. What is the molar ratio of N2 and H2? It's 1:3. 1 is 1 for N2 and 3 for H2. 1:3 is the molar ratio. Now 2 moles of N2 and 9 moles of H2. Which is going to become fast? You just see the molar ratio for this. 2 moles of N2. You are taking N2 first here and here also first. So 2:9. It is exceeding. Is it exceeding 1:3? If you just double, if you multiply this with 2, it will become 2:2. 2 3 is 6. Okay. If you multiply with 2, it is going to become 6. But see, what is becoming? Instead of becoming 2:6, which completes the reaction, instead of that, you have 9 moles of H2. Instead of having 6, you have 9. Means you have, instead of 6 moles of H2, you have some 9 moles of H2. Means you have having this H2 as excess. Means extra you are having H2. What does it mean? This N2 is completing fast in the reaction. If you have 9, then according to this, how much you should have for nitrogen? If you have confusion, you do unitary method. It's you just multiply 3. 3:9 should be the ratio. Instead of that, you have only 2:9. Means you have less number of N2. Less number of N2 means the limiting reagent is N2 nitrogen. Okay, N2 is the limiting reagent. So we'll write that limiting reagent is nitrogen N2. Limiting reagent is nitrogen N2. Right, we just see this. Now this is the way to deal with the question. Okay. Okay. You just copy this down. Now this is some, okay, this is the JEE mains PYQ question. JEE mains PYQ. This is JEE mains PYQ question. Okay, what it is? See, I'll just share as this for your understanding a little. You just see. Yeah, okay. This is like means what's the question is? You are given with this reaction, and yeah, I'll write the given details. Yeah, you have some 20 grams. Right, you have some 20 grams of N2 and some 5 grams of, yeah, you have 20 grams of N2 and 5 grams of H2, and you need to find which is the limiting reagent and what amount of NH3 is formed. How much amount of NH3 is formed? These are the things you need to find. And this is a PYQ. This is a JEE main. What? JEE main 2022 PYQ. Okay, it's a 2022 PYQ. Now, okay, you just write the molar ratio. It's 1:3. Okay, now you convert this into moles. You convert this into moles. This for N2, for 20 grams. See, nitrogen. What is N2 mass? Normally, nitrogen mass is 14. 14 to the 28 is the N2 mass. Okay. Into mass, let us take this as a rough. Okay, this is in rough. You write nitrogen mass is 2 into atomic number is 7 to the 40, so 40 to the 28 grams. This is the mass of N2, and H2 mass is 2 only, 2 grams. Okay. Now number of moles of N2 is what? Number of moles of N2 is given mass by molar mass. Okay, means for 5 is 20, for 7 is 28. 5 by 7 is the molar moles, amount, number of moles. Okay, 5 by 7 is to the molar ratio. Now 5 grams. So given mass is given moles of hydrogen are 3. So 3 to the 6 grams is the given mass. So number of moles of H2 is equals to given mass is 5. Given mass by molar mass is 3 to the 6 grams. So 5 by 6. This is the molar ratio. Okay, molar ratio. First let us see for this. Okay. Now we'll just see. According to this, which is less number? The number with more denominator is less number, right? Suppose if you have 1 by 2 and 1 by 4, which is greater number? Which is lesser? Which is smaller number? Which have high denominator? Which have high denominator is a smaller number. Similarly, which have high denominator is smaller number. So, if you consider the ratio, this is 5:6. Now let us see this. 5 by 7. Okay, you just write down like this. For 1 mole of N3, you are getting 3. For x moles, how much? Okay, 5 by 6 is equals to 3x, and x is equals to 5 by 18. Means you have this 5 by 7. See, 5 by 7 is greater or 5 by 18 is greater? You just tell me. The number with high denominator is less number. So this is the thing. Means you have N2 in excess here. You have N2 in excess. If you have N2 in excess, what does it mean? You have more number of N2. Okay, more number of N2 means H2 is the limiting reagent. Here H2 is the limiting reagent. I'll write down here. Here hydrogen H2 is limiting reagent because it is N2 is becoming excess. You have excess. Needed is 5 by 18, but you have 5 by 7, means which is exhausting fast. This is H2. So H2 is the limiting reagent and amount of NH3 formed. So actually, what's the mass of NH3? It's a rough run, right? I can rub with this. Mass of NH3 is equals to 14 plus 3, that is 14 plus 3, 17 grams. 17, we have 2 moles, right? 2 moles of NH3 means 17 2s are 34 grams. 34 grams. 34 grams of NH3 is there. 4 grams. Okay, actually here what is happening here? 28 grams of here what? It's a 42 star 28 grams here 6 grams. Yeah, 28 grams of into reacts with 6 grams of H2 to give what? 34 grams of NH3. Means according to this you just take one parameter. Since we have N2 in excess and we are being exhausted with H2, sorry, we are being exhausted with H2, right? That's correct. We'll just consider H2. We'll take H2 as parameter. Now H2 initially 5 grams of H2 from 5 grams of H2, sorry, that's 6, right? Yeah, from 6 grams of H2 you are getting 34 grams. Now for 5 grams how much you will get? That's the required question, needed answer for this. You just try this meanwhile. Okay, I'll just rub this if you note this. Okay, I'll give you some 5 seconds. I'll just stop it. If you have any doubt, you just comment me down. Okay. I want more space here. Okay. You can do the calculation faster. You just solve this. 6x. What is x here? X is nothing but the amount of NH3 formed. 6x gives, so 6x, this becomes the equation, right? 6x is equals to 34 into 5. Now you just calculate. It cancels with 2 tables. 2 3s are 2 17s are, and x is equals to 17 5s are 85 by 3. Now you just calculate. 8 plus 5 is 13. It's not divisible by 3. So it will get our answer in point answer. So 3 2 are 6, 2 25. 3 8 are 20, 8 are 24. Yeah. Yeah, 28.3 grams of NH3 you are getting. 28.3 grams of NH3 you are getting. Okay, right. Just note this down. Okay, by this question, we'll just conclude this. Chapter, and we just completed this some basic concepts of chemistry. That is mole concept chapter. I hope you like this video. You just subscribe, share, and like this video. If you have any doubt, you just comment me down. Okay, and I'll make a PYQ session separate for this. If you are interested in that, you just comment me down, thumbs up, and I'm ready to see PYQs. Okay, thank you, and all the best.